thank you all for joining us. This is awesome attendance. In all honesty, this meeting was a fun for the leadership team. It was kind of a last minute, hey, we should probably have a meeting in March, which we talk about, all right, let's broadcast this out. So we really didn't have too much time to let the community know that we're here and what we're doing today. So to have this many people here, and actually to have our sponsors at the last minute, lock in too, definitely appreciate it. So thank you all for joining, and thank you to the sponsors. So today we do have a fun-filled day. All right, so kickoff does say 8 a.m. That's when we open the doors and you guys can come in and grab some food. At 9 a.m., in about 20 minutes, I'm going to kick off a presentation on the software-defined data center. And really, that's going to be the foundation of a series that we're starting with VMware. So it'll make a lot more sense after the 9 o'clock hour. But the VMware, we are kicking off a series on what's called the software-defined data center. The software-defined data center has 4 pillars: storage, network, security, and compute. Software-defined storage is one of those key pillars. So fortunately for us, we have Versto in today to talk about their software-defined storage strategy. And actually, they were recently acquired by VMware. So it's really interesting to hear, one, what their software-defined strategy is, but also how does it merge into the VMware portfolio? Why would VMware want to buy that, right? That's what we all want to know. A little bit later, one of our great sponsors, Technologent, will come in and talk about the next generation data and app availability. Notion, this is all about, one step above replication, right? So being able to replicate data from site A to site B is really important for disaster recovery. But what if that data was active-active, right? As soon as I write data at site A, it's available at site B for readable and writable use. That really kind of changes the dynamics of what we can do, especially with VMware. Imagine if I had a DRS cluster that was stretched between here and Las Vegas. I can do really cool things like vMotion, workload from San Diego to Las Vegas, really cool. So we're going to talk about a technology that helps drive that. We'll then wrap up. We have some awesome giveaways that we talked about earlier. And then for a special treat, hopefully you guys can join us. Hopefully not all of you can join us, because I don't think we locked in a space large enough for this, but we are going to do a V-Beers shortly after. So at 12:30 at the Carl Strauss Brewery Gardens, we will have a V-Beers event. We did have some extra funds to help kick off some appetizers and a couple drinks, but I'm sure that money will go away in about 5 minutes. So try to be there early, at least get one beer if you can, and come mingle and hang out, and hopefully play hooky from work for a whole day. All right, so we do have some free time. This is probably one of the most active parts of the day. We're supposed to kick off our next session at 9, which is like 5 minutes away. But really, this is the most important part for you guys. So some open floor discussion. What types of things are you guys working on? What type of things have you ran into a roadblock? Are you currently working on that you have trouble with? What things do you want to see from VMware? So this time is for you guys. So please don't be shy. Just start talking and let us know what you need and where things are going, or what do you want to see from us. All right, so kick it off.
So one of the issues we're dealing here at CareFusion is we've got 60-some offices worldwide. About 40 of those, we've made the commitment to get rid of the standalone servers and do, two-use servers, ESX hosts. We're doing physical storage of those, and what would love to do is get away from dedicated physical storage at those sites. So take our riverbeds, virtualize that. Right now, we happen at remote sites NetApp. We'd love a virtual storage appliance that would do auto HA on a 2-node setup and just do locally attached storage. Right now, I have come across a number of vendors and can get about 60% of the way towards what we want. Different 60%, different vendors, but have not yet hit the one where on a 2-node setup, I can do local snapshot, replication, auto failover, and the like. Is that something that people go, ooh, yeah, you're not the only one who's interested in that. So can I see a show of hands of people who like, yeah, that's something that you guys could use? Has anyone come across something that would do that?
You see that they showed last year at the VMworld 2012, that distributed storage that they're building?
VMware?
Yeah, VMware.
Right. My understanding is that's a future product.
Not so future, but yeah.
Right.
Looks like that's
But not available yet. I mean,
Yeah.
NetApp's got NetApp Edge. That's a single unit. StoreMagic gets real close, but doesn't have some of the snapshotting and replication pieces. Left Hand and a couple others can do it, but if you want auto failover, they want a third node for split brain detection. So that's where.
Including the FOM on left hand, because that's just a VM that manages those two. So if you can do an FOM with the 2 nodes, you're set. Which is the FOM that you can virtualize
Is that with the Edge?
with left hand.
Oh.
So I hadn't looked in, because I know left hand has a way to virtualize the storage.
Yes, left hand, it's just a split brain. They want to have a third.
But I guess what he's referring to is that the FOM is the management piece that manages this 2 physical nodes.
Right.
That FOM can reside in a VM.
Correct.
So that would eliminate that third physical.
Right. You still have the issue of if that node goes down, starting up on the other, and if where that FOM's at.
What if you did fault tolerance with the FOM? I mean, I know it's...
Right. So that's where we're coming through. When you get the, hey, vendor, do you support this? Haven't yet come across it. So that's why I'm throwing it out.
Is that monitoring agent for left hand, is that a single CPU?
That's the only thing I don't...
I don't know.
It's
I've talked about
it's like an ODF and you upload it, and I've built several of them, but I can't recall if it can run a single CPU, and I know that fault tolerance requirements of a single CPU, but
I typically know.
very low requirements.
Yeah, yeah. I typically know from like a manufacturer perspective, things like agents, we typically want out of band because, you want to be able to monitor out of band the 2 nodes that are running, right? So I can understand why best practice would be to have a third node running. Does that completely break your design and budget?
Fortunately, a number of them, that monitoring piece could be almost anything, from a file share at the local site to a Windows computer that's just on all the time, so maybe part of a voicemail system or something. So there's a number of...
Because I was thinking you could even, and I've done this in other designs, is that third node could be your out-of-band management node, right? So you maybe put vCenter there, you can put, that monitoring agent there, and other devices that if that node would die, it's not the end of the world. You can still survive without vCenter, you can still survive without that, the out-of-bound agent. Don't be shy. I know it's early. Yeah.
One of the biggest reasons that I come and have been coming for years is to stay on top of what are the latest and greatest technologies that VMware is working on. What are they going to be coming out with? I'm not a huge fan of VMworld unless I know that there's with them. So that's what I look for when I come to VMware. So
the question is how do you keep up on the latest and greatest technology when you don't want to go to things like VMworld? The internet, right? The internet is so super powerful. That's actually how I find out the majority of my information. I use, I cried a little tear when they announced Google Reader was being shut down. I found actually another service that I love, I've grown to love now, called Fever. It's an RSS aggregator. You do need a server to run it on. It runs, if you have a LAMP stack running somewhere, you can install Fever. and it's an RSS reader. So I have, links to probably 30 blogs that I regularly follow. And every major company typically now has someone that's leading the charge in social media. So in VMware's case, the number one blogger right now is Duncan Epping, in VMware. Frank Beneman, I think, is number 2, and there's a top 5 that I have from VMware feeding into Fever. And I have some from EMC, I have some from NetApp, I have some from our other competitors, I have some from HP. I have these feeds from different large companies that I want to follow. And Fever, what's cool about it is it starts to learn the things that I like. It senses, what I click on most, and then creates, it monitors those hashtags. So as new, listings come in, it actually grades them and pushes them to the top. So those of you that were using Google Reader and are sad now that it's gone, or will be gone, Fever is actually a really cool product, and you can download a LAMP VM from the Virtual Appliance Marketplace for free. Install Fever on top. So I think the software cost me $30, and it just runs. I have it on a public-facing server, and there's actually a mobile app that can use my iPad or my Android phone to read through it as well. Yeah.
I'm sure most of you know, but there's the VMware Community Roundtable podcast. It's good. It comes out, I think it's once a week. So that's good to have in your car on your way, to work and from work and stuff.
So there's a ton of those, right? So there's the VMware official roundtable. There is actually one called the Brown Bag that runs regularly from VMware Focus. Kyle is actually one of the speakers. He does one that's for those that need to speak Spanish in the room. He does a Spanish-speaking the Brown Bag every week.
Actually tonight at 7. So if you speak Spanish and you want to tune in, I was talking earlier with another attendee. The U.S. English ones happen Wednesday nights at 5:30. All of them are archived on professionalvmware.com. Take a look at that. But they're recorded live in English in the U.S. Wednesday nights, in English in EMEA Tuesday nights, and there's also an APAC one that happens, and I think it's about 3:30 in the morning here. It's not really great, but you can catch the archive. ProfessionalVMware.com, lots of free professional development, lots of experts on there.
So you become multilingual in VMware.
Yes.
You can learn, probably Japanese or Chinese. With the APAC one, you can learn Spanish on yours. What's the Spanish word for VMware?
VMware.
Okay. All right, we're good.
Yeah, you say house.
Right.
House.
I think you had a question.
Yeah, I want to know what everybody's success has been with large database cluster virtualization. Right now, we've got a lot of struggles with trying to get our database team very happy with the setup and virtualization. We're trying to get the communication layer really settled in between database team, storage team, and our virtualization administration. What are some of the struggles people are facing, and what are some of the successes people have maybe been having if you've virtualized large databases? And not just singular databases, particularly SQL Server and mirroring clusters. Does anybody else have a
Define large database.
So let's say around 600 gigs for just a single database, and then maybe 30 or 40 gigs supporting layers in that same instance.
By show of hands, who's virtualized their database infrastructure? All right, out of those guys, who'd like to respond? All right.
My architect answer here is called a big ass roast. we don't have anything really over allocated. We're under allocated in our entire VMware environment, so we have the resources to give to the SQL server. So those that don't have the financial backing, build a big ass host, and it's going to be a complex problem for you.
So I have a question in terms of how you handle storage. When it comes to your storage layer, do you allow your databases to share aggregates with other application storage, or do you give it its own aggregate?
RDMs primarily.
Okay.
We've been moving them to actual, VMware on the data source because we haven't seen any performance issues doing so.
But you're specifically asking on your storage, are you sharing those, like, are you doing runs to Windows machines or whatever?
Yeah, is the over allocations, are those sharing that storage with any other application layer? So say your application causes a big balloon of storage, is your database sharing that balloon effectively?
It could be. I don't have like our storage is laid out. We output storage and get it. We have enterprise class storage. We've never run into an issue where performance of our storage.
If you can, by all means, anyway, avoid application sharing. Even if it's from one shelf to the next, if you can isolate this cluster I have application support, this VM strictly, whatever you need to do to make that happen, make that happen. But yeah, a big fan, even if you're using local storage, single host with a failover, if you're doing something to do full VM level backup of that VM, that's a great way to get started virtualizing your environment until you can afford to grow it in JVM environment and so forth.
One of the challenges that you're going to run into, though, if you dedicate, these 3 drives, 8 drives, 10 drives just to your SQL cluster, is that you're limited, you're bound by the I/O of those drives, right?
Right.
And it's probably not a lot. If you got a 600 gig database, if you're going to mirror 2 600 gig 15K drives, you're basically limited to about 180 IOPS, which may not be sufficient for your SQL environment, right?
Yeah, we're looking at closer to 60,000.
And that's what you should be, right? So then you're either looking at some kind of subset of solid state across, but even solid state drives, right? If you're going to dedicate 600 gigs, even if they're 100 gig solid state drives, you're talking about only 6 of them that are going to be running your data. That's still not 60,000 IOPS, right? Even with most generous count of IOPS per solid state drive, you're still not looking at 60,000 IOPS. So without a shared application kind of underlying architecture, your capacity is not going to keep up with your IOPS, right? So you do need that shared storage pool. What you really need is some really good calculations of what can I share it with, like file sharing, user home drives, things that take up a ton of space with low IOPS that you're going to have to share with your application stack. It's I don't want to make it seem overly simple. It's incredibly complicated to do what you're trying to do, because otherwise, like I said, even with 12 mirrored solid-state drives, you're not going to get 60,000 IOPS, right?
So would your recommendation be to, instead of potentially using like SAN storage for a database layer in the VM world, just maybe still focusing on local storage using something like Fusion IO or some other type of SSD that's local to the actual host?
Sure. So especially for database, and guys, jump in. Sorry, I've just been doing this just like last week. So especially with a 60,000 IOPS 600 gig database, I love local kind of flash cards, right? Whether it's Fusion IO, VF Cache, whoever. There's a bunch of them, right? And there's different options in the way they lay out. I do love that option for you. That's a lot of IOPS for a 600 gig database, right? So it's a ton, right? It's hard to address that. Even in a Fusion IO card, you're not going to get 60,000 IOPS right there, right? Your latency is going to be really low.
Like peak time, talking we're running reports, we're constantly hitting the database. Normally, I don't know, I'd say we probably level out somewhere around, 40,000?
That's still, for a 600 gig database, that's a lot.
It's hard to get 40,000 IOPS out of 600 gigs of
it depends on your storage. As they referenced the Honkin server, ours is a DL980, so 80 cores, 2 terabyte hosts. So we've got plenty. Microsoft SQL clustering, iSCSI, so into raw, on a 3-power array that's doing auto-tiering. The SSDs that we have in that are dedicated to our SAP environment, so it's not getting advantage there, but between the fast and SATA drives, and it's performing just fine. That's one way. That's obviously an expensive solution. I would definitely, at a lower price point, be looking at Fusion IO or something like that to go with it. If you get a multi-terabyte Fusion IO card, and then it depends on what your availability requirements are to go with that. Now, if you need to vMotion it, whatever. But we're also in the process of virtualizing our multi-terabyte SAP databases on VMware as well. So
and you
it's all doable.
You also want to be careful with things like vMotion when you get into those kind of IOPS, right? Because obviously you're highly transactional. You can't vMotion during those transactional periods, right? You're going to have an outage and probably huge corruption, right? So these are systems that need to be pinned to incredibly fast storage and need to be running very fast. There's a lot of calculations that you want to do, and your technology choices are getting kind of narrower as you move into that. So, yeah, there's a lot of calculations to be done. I don't think there's not an easy answer for that. I don't know off the top of my head, but I don't know.
But like, even with our enterprise class storage and, big hosts, you still, even not peak usage, but pretty heavy usage, on DRS taking over and deciding it needs vMotion, SQL database server, or the host, it's cost cutting.
Yeah, I know one thing that we've done, because I work with Daniel, we're parking those systems on a single host. We're not letting them be subject to DRS rules, period. They're just parked. They're removed from the DRS calculation altogether.
I feel like I've kind of, there's been a small misconception. This isn't a current setup we have. Currently we have these servers resting on physical storage. They've got multiple terabytes of, SSD flash memory. They've got, both these systems are working about a terabyte of RAM, so they're capable of handling the load they have. They can handle just about anything we throw at them. But we really eventually want to try to virtualize as much of our infrastructure as possible, and this server has been put onto our roadmap. Now, granted, it's a ways out, but I'm just curious on, I was more or less curious on if anybody's had any success in anything other than, say, Oracle or MySQL database. Obviously, we've seen concepts at VMware, where we had the Oracle database handling terabytes of data going back and forth. But SQL Server has been kind of a different story, and setting those up on virtualized servers, we've been encountering our own issues with latency and storage aggregates failing, and this issue, that issue. So I was just more or less looking to see if anybody had any wins in their pocket, just to kind of get an idea on where we should be and what I should take back to the company on how we should start planning things out. I appreciate the feedback, and thank you very much.
Back to the opposite. Our SQL that we could be putting on the Oracle more counting more like counts in their databases. So it's actually been SQL's been very easy.
I know at SEIC we had a ESC Symmetrics dedicated just to database servers. The entire array was just maybe not cost effective, but it ran well.
And then you look at like the Tintry guys, right? A dedicated cluster array specifically for your IOPS load would probably be sufficient, right? They have competitors out there. Out of respect to them in the room, and you can look them up, or we can talk later about them. But there are. I mean, really, you're looking at a dedicated flash appliance, and then there's the holy war, which I don't want to start in here, which is everything a candidate for virtualization?
Right.
And the answer may be no in your case, right? Because what benefit are you gaining from that except for a common management interface, where you have to dedicate hardware and a lot of it to meet your needs, right? Does that make a ton of sense to add another layer of kind of, that virtualization layer adds some overhead, and is that overhead valuable to you for any reason whatsoever in this particular environment?
See, I would like to tell you, no.
Again, it's
the executive level.
That's the holy war, right? I mean, and that's something that in this group especially, there's probably a lot of differing opinions on that.
So one of the things that, the biggest point why you really want to virtualize anything, period, is the flexibility. Yes, it's not flexible, and now I'm not going to do a live migration, and nothing else can handle this on the storage side. I can't do motion. But if at some point you're ready to grow, you're not building a whole other server, migrating databases, pointing applications, one server, whatever. It's a virtual machine. It doesn't care what's underneath it. So you have the ability to do this somewhere. You have the ability to back it up somewhere. And that's not as easy if you don't virtualize it.
I think at our executive level, they're just looking at it as another point of redundancy, just being able to fail over to an additional host somewhere over on a different site without, with a much lesser degree of outage. So, but the thing is I've been trying to explain to some of our architecture team for a while, it's not a matter of, do we want to decrease this outage window, it's a matter of are we just throwing resources in something that could be solved by using, like SQL servers, native mirroring, putting that mirror in a different site and just making sure that mirror is getting proper feed, making sure that they have proper communication. And with Server 2012, you've got things like always-on availability. So I'm trying to stress, native solutions as opposed to going on to virtualization for something this massive, because it's a huge undertaking. And again, that's just why I was looking to see if there's any wins. Maybe help build my confidence on if these can be virtualized effectively.
And with the vMotion option down the road, right, you have to pretty much turn the server off to overwrite in your space. It wouldn't be live. Your database mirroring is going to lag dramatically with the 60,000 IOP load, right? During peak times, your SLAs are going to be way out of whack, or at least you want to set your SLAs to be that kind of max time, the journaling and that kind of thing. I don't know what your pipes look like, but moving 60,000 IOPS across WAN to any other site is going to take a while, right? I mean, regardless of the size. So there's a lot of things to consider either way. Again, it's the holy war of whether or not the virtualization layer adds anything in this particular environment, which either way, you can still build it the same as the other, right? It's just a matter of, you're looking at probably a lot of dedicated hardware.
By show of hands, who has open seat at the table? Feel free, guys, to sit down.
We don't bite.
Make some friends, meet new people. All right. Any other topics? We have time for maybe one more.
Disaster recovery.
Disaster recovery.
What are people using to back up their VMware environments, and what are they using to monitor? Right here.
All right. That's kind of threefold. Who's backing up their VMs? A lot of hands went up and then went quickly down, but then probably realized, crap, maybe I'm not backing up my VM.
Some of them?
My brother, who could get them back? I'm backing this up for the purpose of archive, right? Archive, and, perhaps, restoration if all else fails.
Snapshotting doesn't count.
Yeah, snapshots are not backup. Snapshots, part of my French, are for the oh shit moments, right? VMware snapshots in particular are used and should only be used for, I'm updating something on this VM and I want an easy way to roll back. It's not, hey, it's Monday, I'm going to create a snapshot.
Rick, can you explain that to the rest of the world?
Yeah, it's a huge problem, and that's where education is huge, right? Because snapshots from VMware change the characteristics of the virtual disk dramatically, right? You create a snapshot, you're closing the parent virtual disk, and you're creating a delta, right? That delta is thin provision, and there's no limit to how large it can grow. That's a recipe for disaster, right? One, you're going to impact performance dramatically by a tune of 2 to 4x, right? You have to zero the block and then write your data, right? So you're impacting performance, and because it can grow forever, as soon as that data store is full, all your VMs in that data store are turned off. That's bad, right? So snapshots are not long-term archives. Push that out to your compadres out there. Right? Unfortunately, sometimes it takes an outage for someone to realize what they've done. I know a lot of people that actually created PowerShell scripts that run on a nightly or even weekly basis. They just delete all snapshots. But I don't care that there's a snapshot out there. It's going away because I don't want to crash my other VMs. Yeah.
Is there an easy way to see snapshots through if you're just if you've got developers who are snapping?
Absolutely not.
Yeah, you just gotta, okay. Because that's, I run into that word.
With a client, you have to look at each individual VM. Yeah.
I don't want to steal any percentage, but for anybody, it amazes me that not that many people know about it, but there's a free application out there that people who are way smarter than me have written called the V-Check script. If you're not using that, go read about it, get it, and tie it to a schedule task. While using VMs, have it run it once a day. It tells you everything you need to know if it's going wrong in the environment. Pretty much.
Yeah.
V-Check. So if you're not using, V-Check. Read about it, really download it, implement it. It's very simple setup now.
To lay out over that, there's a PowerShell script called vcheck. There's also a tool called RV Tools. Yeah, RV Tools. It's a C+ Windows application that plugs into your virtual center, and you can do a lot of cool things like do VMs have snapshots.
There's also Power GUI.
Power GUI. There's a number of, if you know PowerShell, it's literally a single line PowerShell script to export, what VMs have snapshots.
It checks the other thing too. It checks like on CD, event motion, and other stuff too. So pre-check is really powerful.
It's more of a like a daily report. It's good, to get that dump, like maybe daily of how your environment looks. Includes all that. Okay, so snapshot's bad, right? Backup. Who's doing like traditional agents in VM type backups? You are?
Same snapshots or
Awesome. Anyone else doing an agent?
We do both.
Okay.
For your SQL, some of your things that you need, SharePoint, what have you, where you
application
need
consistency.
Right. You have to do it in guest agent. The rest of it would post-based.
So, good that you brought that up, because that's the main reason why I asked who's doing in-guest agents. For quite some time now, VMware has had this API called VADP, for vSphere APIs for data protection, and you have the ability to offload backups, right? So no agents within the guest. And every major backup vendor out there supports this. Commvault, Symantec, EMC, etc. Every major vendor out there supports this. Huge caveat, though, is you can't do application consistent backups via that method. There is VSS integration, but I'll warn you that the VSS integration is done through VMware tools, so make sure your VMware tools are always up to date. But two, it's best effort. There's no air checking. It's VSS call, shoot the dice, back up. So if for some reason VSS did not engage the application consistency within SQL, SharePoint, etc., if it's a Microsoft, right, it has to be Microsoft or Microsoft supported, you may or may not have application consistency. That's why I always recommend having, on those VMs, having the native agent installed, because you're guaranteeing that the application is being quiesced and then the backup's being taken. Who's doing replication? You mentioned you're doing replication at the SAN level, right?
We also, so part of our DR is those backups go to the data domain, those go to our DR site, and then we have scripts that run in the DR that will automatically deploy those backups to servers. We also use SRM with Protopoint for our tier 1 agents. So we're using the point replication SRM to manage.
Awesome. Anyone else out there doing SRM? Site Recovery Manager? Couple guys.
Really good product.
Yeah, it's an amazing product.
Long way.
By show of hands, actually, who's doing replication? So every single one of you guys should be using SRM.
We're dealing with the SRM vCloud Director, waiting for the...
Yeah, so huge caveat there. In the current shipping version, if you are running vCloud Director, it's honestly a pain in the ass to replicate that.
By a show of hands, who is using vCloud Director right now? A couple folks.
So for the majority of people, replicating wouldn't matter anyway. But there is a problem. SRM is not vCloud aware. vCloud creates a lot of metadata tied to the virtual machines. There are workarounds, and those workarounds include obviously the virtualization of your vCloud environment and protecting that group to come up online first at your VR site before the underlying VMs start out. It honestly is a pain to design and build it out, but it can be done. There is hope at the end of the tunnel. There's a huge light and, major updates to code are coming. There's a big conference that happens every year, and usually VMware makes announcements of new versions. I'm just, I'm guessing.
And Rick, because I don't think we're under NDA for this, I thought there was something coming out a couple months from now that addressed this.
I don't know.
I'm waiting for that big event.
It's possible. I'm safer saying that there's a big event that usually things happen at. Because I actually work for the company. You don't, you can say whatever you want. I can get fired. So awesome. To take 2 more minutes, I'd love to know what you guys want to see from the VMUG. Are we hitting the mark with events like this?
This is our best attendance in years, so I would say that this subject obviously has interest. Was it this subject, or was it just this was a good day? Because, this is literally our best attendance in year and a half.
Is it the food?
Is it the toys?
That's the middle of the work.
I think it's maybe it's because of people's schedule. Any part of the year for available.
Yeah, absolutely. I've been coming to VMUG for years, and it's the ability to come and listen to like Rick. There's people, believe it or not, that think I know what I'm doing. I tell them there's one man that I stand, bow to, and that's this guy. And to be able to listen to what he brings to the table, listen to what everybody else in the room brings to the table, and for anybody who's been coming for a while, you'll see people like me hammering vendors that get up here. So if you're a vendor and you come up here and you have something that's very mediocre and you haven't really done your homework, this is an open forum and we're going to blast it with it. So that's what I like about it. This is a group of engineers that face the daily struggles that we all face, and it's an open forum for that. That's what will continue to bring me
To push on that 1 second, this is an open forum, guys. So during presentations, don't be afraid to say, hey, that sucks. But here's how it could be better. Because I'm sure the vendors want to hear that too, the vendors that we do have in here. Or if you'd like to know more about how could this relate to me, ask the questions. Because I guarantee there's a lot of smart people in the room, and your question will most likely be answered.
There are no dumb questions.
Well, along that note, too, if you find something in the presentation that you're using, that you've had good success with, other people experiencing that pain might want to know that, because that might point them in a direction for a solution themselves. That's the other part of that coin.
I can tell you, with Burst, though, which will be up shortly, probably not so much, because there are, not too many people are using the product. There are new technology, and it's now going to be rolled into VMware's family. But anything we talk about, feel free. Like I said, this is your VMUG. It's not my VMUG. It's not Lawrence's VMUG. It's Bert's VMUG. It's your guys' VMUG. You had a comment back there?
Yeah. This is my first time at one of these events, so excuse me for asking some of the questions. But we're standardized on backups with using vRanger Pro, and so I'm just I kind of blindly went into that like 3 years ago because everybody said, oh, it's a great product, it's Vision Corp. Anybody else using that product? Have they had good experiences, bad experiences, like get off it now type things, or I'm at a crossroads where I could change. So should I continue down that path, or I know some people are very big on like Veeam or something else. So
we've gotten rid of a lot of vRanger.
Have you?
Yes.
Is there a reason why?
We didn't like the product.
Okay. Failures and bad restores?
We had issues in various areas
with
the product. So, we've removed it more times. We prefer Veeam. So, Veeam's our favorite right now. Really not throttling it. Yeah, if you're not throttling it, it'll crush you.
Oh, okay.
It's still a good product that you use really.
We had another vRanger user up front.
We've been using it since like 1.0. storage plus bottom, just for our VMware environment. It works great for us.
Restores have been fine.
Yeah, but we do socket storage with it for testing, and we still back up some of the data stores with net backup as well. We don't use net backup for VM.
And they're also one of the only few that are agents as
Right.
far as like a backup solution is concerned, which we definitely prefer.
Yeah. Yeah, I mean, that's kind of what we're looking for. 'Cause a lot of times our developers throw up servers that kind of come up out of nowhere.
Yeah,
And
I mean-
the Ranger picks them up automatically.
Right, and I would imagine it's got about the same statistics as Veeam does, because we usually back up, 100 or 200 VMs in a couple of hours. So, I really like that kind of efficiency, but that's all VMware. It's all change block tracking, it's all the storage APIs and everything else that's in it.
Yeah,
By show of hands, any users that used VMware as a VDR? By show of hands.
Tried it before.
Did you think it sucked?
No.
I used it for an isolated environment that we wouldn't otherwise have backed up at all. And it took a lot more hand-holding than I'd ever, and mind you, this was a couple of years ago.
Right.
It's not the current. This was the 1.0, 1.1, 1.2 timeframe. It took a lot more hand-holding, but it certainly worked. It wasn't that big a deal, very space efficient. And for that simple, one of the developers in this test environment screwed something up, and they did the, oh geez, would you please rebuild? And I go, here it was as of yesterday. Worked great.
By show of hands, who's heard of VDR? Okay. By show of hands, the VDR product has been deprecated with a new version. Who's heard of VDP? A lot less people. So in the vSphere 5.1 product, they released a new backup technology called VDP, or vSphere Data Protection. It's a lot better than VDR. It's a lot better. It's like night and day versus VDR. But seeing that only one person used VDR, you want to know the difference? The best part about it, though, is if you're a vSphere customer, it's free. And you can do backups. If you're not doing backups today, it's an easy way. It's a virtual appliance. You attach some VMDKs to it, hopefully from a data store that's different than where your production data is living, and you can do backups. There is an advanced product that they just released recently that is a paid subscription, right? And that's for larger data sets. So SMB Robo, the built-in free is probably perfect. But if you need something a little bit larger, and you build the backup multi-terabytes, VDP Advanced is now available as well.
Can that use just regular NFS targets, or?
It can use any storage you present to it from a VMDK fashion. So that VMDK can come from NFS, it can come from a VMFS data store, it doesn't matter.
What's the snapshot?
No. It's just a traditional, point in time. It's the way it does backups. It does it them in incremental fashion, the backups, but they're always full backups. So it's kind of like Tivoli TSM. You guys would use that, or Avamar from EMC.
Synthetic. Oh, it's the synthetic pool.
Yeah, they're synthetic pools. Yeah.
The VM snapshot state was the backup?
Yep. So it uses VDP, so that means it snaps all the VMs, then engages VSS, it does a copy, and then removes the snapshot.
You have to have a bunch of them.
Correct. So before I kick off the discussion on software and data center, which I'm going to have to run right through because we're way behind it. Obviously, it looks like the open floor discussion is probably the crowd favorite, so we'll keep that in mind for the next meeting and maybe allow a lot more time for this, maybe one less presentation, and instead just do a couple hours of open floor, because you guys are really engaged. That's awesome. A couple things I wanted to announce. We are having an all-day event in April. I can't remember the exact date, 21st? 30th. 30th. It's the 21st, correct. April 30th at Hyatt Regency. It's for those of you that haven't been to an all-day, but if you've been to like a V Forum, it's done meeting. It's a VMUG all-day. It's like a mini VMworld. So those of you that can't or don't want to go to a VMworld in San Francisco, there's like 10 sessions on different topics. The best part about it, in my opinion, because I'm a tech head, I like to do my hands dirty. We're gonna have hands-on labs, and you'll bring your own device, hands-on labs. So you don't have to wait for a workstation to open up. You can just bring your laptop, bring your iPad, whatever you have, sit down, log into a hands-on lab. And what's even better than that is you can take it home and do it at home. And I'm working with the team that's providing this. So, a little background, VMware has this project we're working on called Project Knee. Project Knee is hands-on labs available from anywhere, anytime. So there's a huge data center they built up with the same hands-on labs that they've been doing at VMworld for the past few years. But now you can log in with an HTML5 web browser and do them anytime. They agreed initially to create logins for everybody that wanted it to use for 24 to 48 hours after the event. I'm going to push on them really hard to just keep those accounts open full time, because the project is still in beta, so they're not, they want to try and limit the amount of people that are on it, but what's another 100 people, right? They should have the infrastructure, and if they don't, they'll teach them that they probably should ramp it up a little bit. Yeah.
Knee or knee?
Knee, N-E-E. So if you do a search on Google for Project Knee, you'll find out some information. Actually, if you go to hol.vmware.com, you can find out a whole bunch of stuff. There's a community site all driven on it. You can actually sign up for the beta program, and you may even be able to get a account today if you want. All right. So to kick off this series, so to speak, on software-defined data center, I'm going to kick off and talk about what that means from a VMware perspective. So I do this day in and day out, talk about this stuff and try and help push our customers in the cloud direction, because this is where things are going. Just like, we talk about in 2001, 2002, hey, virtualization is coming, it's here, you need to start virtualizing stuff. Now the discussion is, hey, cloud is here, and it's where you need to go, because it's actually being driven from the C-level down. Virtualization kind of came from engineering up, right? Some server admins, typically would find it and say, hey, this is really cool. I don't need to build servers day in and day out. I can just deploy a virtual machine for people that need it. Cloud is coming from the top down because, CEOs and CFOs are, the best thing is they're flying somewhere, and in the magazine, so Spirit magazine on Southwest, centerfold is about cloud, and they read it and they're like, we should do this. And they go to you guys, the engineers, and they say, do this. I read it and it looks cool, and it says we'll save a lot of money. This technology is driving innovation, it's driving cost savings, it's driving a lot of things, and it's coming, like I said, from the top down, so we be aware of it. So to set the foundation, what the directors and C-levels of organizations are focused on, and what business is focused on, is obviously the applications and the end users. So we have to level set that, in our clear line of sight, our focus should always be on the application. When something goes down, the business doesn't come to us and say, hey, why is this switch down? Why is this storage rate down? They say, why is this application down? The application is what's important to them. An application being down could cost a company money, it can cost a company time. There's significant impact when applications are down, and no one really focuses on the infrastructure, right? Infrastructure has also been typically complex. Servers, networks, storage, security, switching, routing, IPSs, IDSs, DMZs. It's complex and confusing, right? We're trying to get to this model of simplicity. Private cloud within our data centers, public cloud being able to burst out to, right? Or some workloads may actually be better fit to run in AWS. We shouldn't be afraid of things like Amazon or Google. We should actually embrace it, because it might actually be better for the business. And there may be a combination of the two, what we're calling hybrid cloud. Right? So again, focus is on the application. Software-defined data center is actually the infrastructure that drives this. But again, the goal is meeting SLAs and ensuring applications are online. So virtualization definitely paved the way. Made things very simple and easy. You know, deploying a traditional rack-mount server was costly and timely. You know, roughly $10,000 for an average size x86 server, roughly 10 weeks from the time of unboxing, racking, cabling, powering on, testing, validating, installing operating systems, patching, blah, 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 and then actually turning it over to the person that actually needs it. You know, on average, 10 weeks, about 10 grand. Virtualization, obviously fast forward that, and saw instant gratification. You know, 2 minutes to deploy a template, and it's really cheap because we're getting mass consolidation. The harsh reality is there's a lot more behind the scenes that are driving that virtual machine. Things like the networking, the security, load balancing, protection, the storage, the availability. Virtualization isn't as cheap as we thought it would be. Yes, we can take a $10,000 server and put 30 virtual machines on it. So we had a huge savings of that $10,000 mark. But, you know, for most shops, they actually had to start implementing SANs. Most companies had no idea what even a SAN was or did before virtualization, right? And that's a huge, huge investment. So to help drive the message, I like doing a few analogies to help get you to understand what software-defined data center really means. So I travel a lot, so I like using airplane analogies. You guys know it. The 787 Dreamliner has over 6 million parts, including the faulty batteries. Right? Luckily, though, there's one of these guys in the cockpit flying the plane for us. He was pretty happy. It's scary. You know what? I sometimes see them at the bar, and I'm like, hey, what are you doing there, buddy? But then I think about it, and I'm like, maybe you could have a few drinks. Because the question is, does the pilot know about all of those parts? Furthermore, does he care? Does he care about how the latch on the lavatory door works, or if the window shade on row 10 is malfunctioning? No. It doesn't matter to him. The scary question, though, is he actually even flying the plane? So let that bake in a little bit, and I'll come back to it. So for a license plate frame, what type of plane is this? One person.
P51.
Who said P51?
The Mustang.
Right. So this is a old model P51 Mustang. Early model. Early model P51 Mustang. The most advanced airplane of its time. Between 30s and 40s. The pilot had full control of this aircraft. Hardwired systems to the yoke that controlled, the elevator on the flaps, the wings. They, dip, dive, dodge. Dive. Right. Dive, right. I was looking for someone to catch the reference. This aircraft, right? If there was an oncoming, attack, you just push the yoke in and the plane just dive down, right? It had full control. Fast forward to 2000s, 2012, 2013 now, B-2 bomber, the most technologically advanced aircraft of today. In fact, this aircraft is so advanced that no human can fly it. There's actually 4 onboard computers and an advanced fly-by-wire system. If those systems were turned off, the plane would crash almost instantly. There's no pilot or human in the world that could control that aircraft manually.
They're running VMware?
I hope so.
It's not Windows, right?
So let's fall back to our 787. What's the pilot actually doing? Is he flying the plane? So what's happening during the pre-flight stuff? You're sitting down in your seat. The flight attendants are saying, this is how you buckle a safety belt. You know, there's a life vest under. This is how you put it on. You use a tube or pull a strap. There's face masks that come down. You know, the bag may not inflate. Do your bags first before the child or person acting like a child next to you. And then there's 6 emergency exits, 2 forward, over wing, back. While all that's happening, I've heard some. They get funny sometimes, and most people don't notice when they've made a joke, but they you know, they'll have some pretty good crackers there. So while all this is happening, the pilot is actually sitting with his iPad. So most of them now have iPads, running through the flight book, going through the checklist. Okay, check this knob, check this light, check this, check that, blah, 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 blah. And then they're also getting information from the tower and FAA of their flight coordinates. So this is a flight San Diego to Phoenix. Here's the flight pattern that you're taking. And they're typing it into the flight computer. We're going this coordinate to this coordinate to this coordinate to this coordinate. Okay. The only flight time is actually taxi, takeoff. Once they reach a safe altitude, around 10,000 feet, they engage autopilot. And then that run book starts. Run book says, take me up to 36,000 feet, turn at these coordinates at this time, and then when they approach for landing, autopilot's off, the pilot has control of landing. The funny thing is, I actually talked to a few pilots about this. Most modern aircraft today have the systems to do auto takeoff and auto land. So they actually just stop at the end of the runway, hit a start button, grab their mojito, and the plane just goes. It's actually the airlines that probably want to make sure that they're getting their money worth out of the pilot to actually have them take off and land. It's probably liability reasons too, but the aircraft actually has the technology to do this for them. So statistics are staggering. If we look at technology in the 30s and 40s, there's roughly 1 death for every 1 million miles flown. Fast forward, we're around 1 death for every 2 billion miles flown. It's roughly 2,000 times safer to fly now versus the 30s. Makes me think about another statistic. Love stats. What percentage of auto accidents are caused by mechanical failure? Any guesses out there?
38.
10. What was that?
1%.
38, 10.
Less than 1. Less than 1.5.
Yeah. Under 5. Under 5.
3% of auto accidents are caused by mechanical failure. Human error causes roughly 94% of that. The funny thing is that 3% accident rate of mechanical failure are typically attributed to malmaintenance of the vehicle. Not replacing tires, not replacing brakes, not maintaining the car. So that 3% is actually kind of jaded because the majority of the 3% are caused by humans, not the actual mechanical failure of the vehicle, right? So let's factor in this reality. This is a Los Angeles interchange. This is why I never go to accounts in LA. Anytime I have a rep or anyone say, hey, can you come to LA? I say, I'm busy. It's sad, but I'd actually much rather fly anywhere from San Diego than drive to LA. Let's factor in this reality. How do we scale? If the freeways are like this already, and we're adding more humans and more drivers to the road on a daily basis. What do we do to fix this? We can build up, I suppose, but that doesn't work everywhere, right? LA actually has some multi-level freeways. San Francisco has some as well. But that won't work like in urban areas. You know? If we look at the statistics, these stats are actually coming from China, and I'll tell you a little bit about where America is right now. But in China in 2000, there were roughly 4 vehicles for every 1,000 people. Fast forward to 2010, it grew at a rate of 10x. And it's speculated that that growth rate by 2035, there's going to be 310 vehicles for every 1,000 people. Here's the scary fact. America, where it sits today, there are 610 vehicles for every 1,000 people. It's a lot of cars. So how do we fix that scalability issue? Introducing Google Car. Some may laugh and joke about this, but there's actually legislature already put in place in the state of California and Nevada that are paving, no pun intended, paving the road for vehicles like this.
He's already do that.
15. Yeah, that was the magnet system that GM was working on. Google Car uses a number of local sensors, right, to control what's around it and know what's around it. But it also uses extremely precise GPS and Google Maps information to know where roads are and things like that. We look at the stats of this. In 300,000 miles of driving, there's only been 2 recorded accidents. One when the car was being driven manually, and secondly when it was rear-ended at an intersection by a car driven manually. There's been 0 accidents caused by the automatic system built into the car. Obviously, 300,000 miles, not that much data, but things are looking pretty good, right? So what's the cross-thread across both of those examples?
Real people. A lot of application reliance.
The common thread is, we can't live on our own. We need help. The common thread is, to solve scale and complexity, we need to relinquish some of that control. The control has to be relinquished to programmable software. The auto flight pilot, the auto flight controls in the airplane, right, and the auto driving vehicle software that sits on top of hardware, right. So with that, I introduce this idea. This is an idea that we've been working on for quite some time. And,
it'll be back.
The concept's simple. There's these cybernetic terminators that help us with our day-to-day lives, right? Now, it's a funny analogy and interestingly scary because that's actually where we're going. You think about the military, there's drones, and they're building obviously iRobots for military use. The movie producers and creators of TV shows and movies obviously are way smarter than they think they are. They should probably be in IT rather than producing movies, but they probably would make less money. So good for them. The reality is we do need to move to a technology like cloud, right? Cloud and software-defined data center. So we've been talking about cloud for a very long time, over 5 years. So what's so different now? So we've reached the tipping point now where infrastructure has been transformed. We're at a point now where the technology is there to actually get us there. We've been talking about it for a long time, but the technology just wasn't there. We were kind of, prepping people for, hey, this is coming, this is coming, this is coming. Now it's here, so it's like either crap or get off the pot. So what are the big advances that have happened that enable this? Obviously, the proliferation and standardization of x86. I'm sorry to any Spark or RISC lovers out there, but they're losing the chip wars.
Well, ARM is coming.
ARM's coming. ARM's great for the mobile space, right? Very high powered and low power consumption. But for mainstream computing, I think x86 is here for a while. Could ARM go into that? Hey, who knows? Competition creates innovation, so we'll see what happens. But for now, x86 is the leader. We look at a pretty graph that probably doesn't mean much, but we can see that x86 is obviously gained market share and dominance. And interestingly enough, somewhere in the middle with no exact relevance at all, VMware was founded in 1998. I don't know why marketing does this. It's like there's no spike like after. There's just like, hey, VMware was created, and the growth trajectory was the exact same. So, awesome. To wrap up on x86, obviously we're seeing mass consolidation, virtualization of our compute workloads, but x86 is also dominating now in other pieces of the infrastructure. Storage, for example, I'll take the EMC route. 5+ years ago, a rep would have came in, beated their chest, and talked about how awesome Symmetrics was because of how proprietary it was. Cold start of joints, proprietary ASICs, custom this, custom that, built to do the job at hand. When I talk about storage now, or an SE talks about storage with customers, hardware is talked about maybe 2 minutes. Yes, it's commodity x86 hardware running Intel processors. And then the other, 58 minutes of the meeting, we talk about how awesome the software is. Ingenuity code, built to run, high-performance workloads, automated storage tiering, cache, blah, 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 all software. Same thing's happening in networking. Cisco would have came in, beat at the chest, talked about how awesome the ASICs were and their Catalyst line. Now there's this huge wave of FDX, right? Extracting the intelligence out of that proprietary box. They're now moving to x86, and their controlled workloads run as virtual machines on x86 hardware. It's happening across the board. Which leads into the second piece, mass virtualization. Obviously, we're virtualizing workloads, SQL databases, Oracle databases, SAP. I'm actually working on probably one of the largest SAP installs for a branch of the military. 60,000 IOPS is a lot. They're close to 6 million IOPS, and it's close to 6 petabyte database. One of the largest database installs out there, and they want to virtualize it. And I'm like, you're awesome.
You win.
I will not want to get my name anywhere associated with that project in terms of wrench turning, because it will fail, and then they'll figure out what was wrong with it, and they'll fix it. That's just what happens at that type of scale. It's impossible unless you. I would say it's impossible unless you have huge pockets, but they're in the military, so. Yeah. But Obama's taking money away from them, anyways. That's politics. We're talking politics from VMware. Mass virtualization is happening, though. I already said it happened on the compute. It's obviously happening now on the storage. We're talking about Versto in a little bit, and it's already happening. Cisco had the Nexus 1000B for quite some time now, and there's other vendors now that have the network products. Security, same thing. F5, you can get a number of their products now for VMware as virtual appliances. Cisco ASA, virtual appliance. It's happening. The third big piece, mass automation. This is the last pillar, right? We build the infrastructure, cable it once, design it appropriately, but then automate and orchestrate on top of it. That's the cloud, right? We haven't been able to do that in the past because mature products did not exist. A lot of innovation has happened. We're actually not at a point now where you could walk in, pull something off the shelf, and at the end of the day have orchestration and automation. The advent of NewScale, Service Mesh, ServiceNow, Dynamic Ops, which was acquired by VMware as well, is now called the vCloud Automation Center. There's a number of other options, OpenStack being one of them. Automation and orchestration has matured. So the question is no longer what is cloud, it's how. So here's the big idea. I already talked a lot about this. Virtualized software is replacing specialized hardware in the data center. We're no longer going to buy these proprietary big black boxes. We're going to buy commodity x86 hardware, and there's going to be virtual machines with policies and profiles that dictate what they are and what they do to drive that workload. So take a step backwards. What does this look like? We have our traditional silos, Windows, Linux, database, etc. Each one of those silos typically had compute, storage, network profiles associated with them, right? And in some environments, like mission critical, may have their own entire storage array dedicated to itself, right? Concept simple. We abstract all that hardware, we pool it, and automate it. So abstract the intelligence, pool. We're already doing that with compute, right? We've taken a number of x86 servers and created a DRS cluster. That's software-defined compute. That's virtualization, right? Very simple. And we carve off these virtual data centers on top of it. The virtual data center dictates what that environment does. So I may have a PCI-compliant virtual data center that has all the security, network policies associated with it. And I also have a storage policy associated with that. So this is high performance, being replicated, etc. We're extracting the intelligence away from the proprietary hardware. So automate within the silos and integrate with the virtual platform. So there's another way to show it. Abstract the intelligence, server management. Again, we've already done that with virtualization. On the security side, we've actually been doing this for quite some time already. vShield. vShield app, vShield edge. That's removing the requirement of a physical IPS IDS, physical DMZ constraints, right? We can do all of that now in software. Networking, the train is full steam and it's happening. Some may argue, Nexus 1000V, distributed virtual switching, that was like the first step, right? Baby steps, that was the first step. Now things like OpenFlow and Nicira, right, are going to complete that picture. Storage, that's the next huge hurdle. Versto is a huge piece of that, and I guarantee it, other storage vendors are well down a path on the roadmap of what they think software-defined storage means. Exenta, one of our sponsors here, they've been doing software-defined storage in their eyes for quite some time, right? It's software that runs on commodity hardware. It's a virtual appliance that runs on your VMware environment. From a bill of materials aspect, what's this look like? If you're going to build out the software-defined model in cloud in your environment, and you're 100% VMware focused, what's this look like? We have vSphere on the bottom. We've been doing this for quite some time with vSphere, right? Distributed switching and vShield have been merged into one suite called vCNS, or vCloud Network and Security. For disaster recovery and replication, we have Site Recovery Manager. Even if you don't have a native storage array, we can do host-based replication with vSphere now and automate that with SRM. vCloud Director and vCloud Connector. vCloud Director allows you to take that virtual infrastructure and carve it out and set policies, right, to each EDC. vCloud Connector allows you to connect to adjacent vCloud environments you may have, whether it's internal or external, and that's how you jump between environments. On the very top, that's the automation center. That's the orchestration and automation engine, as well as the front-end portal. End users log into that portal. There's a content catalog, CMDB. They choose what they want, and based on what they want, it could land in the appropriate environment. On the left side, in the lighter blue, that's your private data center, your private cloud. But there may be a public cloud that's more appropriate for that workload. This web app that they've chosen from VCAC may be best fit to run in AWS. Well, VCAC can automate that into AWS. And obviously, I'm not going to deep dive too much, but you need to be able to monitor it, ensure performance SLAs are being met, as well as anticipate growth. And that's where vCenter operations comes in. On the far right, business management, that's VMware acquired a company called Digital Fuel. It's all about knowing and being able to create reports, knowing where things are living, internal, external, whatever the case may be, at an app level, so knowing what apps you have, where they're living, and how much it costs you to run them. So those are the CX level reports that you push back. It grabs the real data across the environment, tell your C levels, here's what we have and here's how much it's costing. Smack dab in the middle of vFabric application management, a full suite, dedicated to middleware, right? App dev happening within Spring. You have to run that somewhere. If you want to run it internally on your private cloud, vFabric is that answer. There's also some really cool automation stuff in that space as well. Lucky for us, VMware made it very simple. They created a vCloud suite. So one single SKU now will give you really everything you need to build your cloud from a software standpoint. So, moving to the model we're at today where, even with virtualization, it still takes 5 days and a significant amount of money because we have to interact with different teams to create policies for each application. If we build the foundation first and then, create policies at the VDC level, the applications just get dropped into buckets that are automatically pre-configured, which means we're cutting down our deployment time back down to the minute mark. We're also automating that so the end users or line of business can do it on their own. So with that, I thank you for the time. Are there any questions before we hand it off to Greg? Any questions?
Do you know how many sockets are going to be in the vCloud suite by default, or is that no sockets?
So vCloud Suite from a vSphere perspective is Enterprise Plus.
Okay, so that's starting off with that Enterprise.
So you're starting off with Enterprise Plus. There's no option around that. And you pay for the suite by the socket, right? You're down to the limits of Enterprise Plus. And the great part about the vCloud Suite, though, is everything else that we typically have to pay a la carte for. So, for example, SRM was typically like a per VM by bundles of 25. It's all you need.
What about the HA connector for vCenter? Is that also included?
It's all part of Enterprise Plus. So everything that would come with Enterprise Plus, vSphere, is part of the vCloud Suite.
No, that vCenter HA.
Heartbeat. So vCenter Heartbeat. vCenter Heartbeat is still a separate product. And I argue its relevance. I know VMware doesn't, VMware obviously would love to sell it. But I argue that it causes more pain than benefit, especially since vCenter isn't required for your environment to still run. But I've had to work on some accounts where, for whatever reason, they felt that it was, a mission-critical application that they want to tie to and looking for. And once you jump over hurdles and pain of bringing it up, it works and does what it should, but it's a painful process. And it's really expensive.
And how do you normally take care of your vCenter pilot? I know it doesn't require it to work, but if it does blow up, you use your standard backup to recover it.
So obviously standard backup policies to ensure you have a solid backup of that machine, but obviously relying on VMware HA, right? If that host would die, VMware HA will restart vCenter on another node.
Sure, and this is assuming that our vCenter floats inside of our hypervisors too, right?
Right.
How many people are still doing it external? Because
It's actually a good question. By a show of hands, who's still doing physical virtual sessions? Okay, why?
Yeah. We don't know.
Paranoia? Size? Okay. It is a massive workload. What I'm starting to see more so of is the building of these out-of-band management clusters.
Right, and we use VMware for that.
Right.
So we create all these management boxes inside of their own VMware, including vCenter.
So you have a separate, maybe 2 or 3 node management cluster. That's where vCenter lives. So, the biggest thing about virtualizing vCenter is knowing where it lives. If it were to go down, if you have a 32 nodes cluster, you're going to spend some time trying to figure out where it is, because I can't use PowerShell against vCenter to find out where it is. It's down.
You manage that with DRX rules and
So thank you very much for bringing that up. So that's why, there's technology like DRS affinity, right? So you can dictate and say, this virtual machine, you either do a must or a should rule, right? So should means it should live on this host, but it could be restarted anywhere else. Must forces it to run on specific hosts. Keep in mind though, doing a must rule, if that node goes down, the VM isn't restarting.
Yeah, I noticed that the must rules are kind of dangerous about your affinity stuff, because they'll just die and they'll die and they won't tell you whether you're dead.
Right. Yeah, that's why should rules are better, because you can actually dictate, should live on maybe one of these two hosts, so you know where it is.
Right now, I use a dedicated ESX host with local disk for vCenter. Our main AD server can use VRANGE just to replicate it back to the cluster in case of VR. But I can also move it, storage, vMotion, if I have to do some maintenance with that specific host, like I said. Otherwise, it lives both on local disk.
I've seen that as well, and there's nothing wrong with that. It's actually, the importance of vCenter isn't that great. It's obviously the central management tool, but if work go down, workloads are not going to die, right? And actually, VMware HA will still perform without the virtual center running. HA runs natively on the ESX host. So even if virtual center were to die, each host is still aware of what VMs are running on it, what VMs are running on other nodes, and what to do if there was a failure.
Is that also true with resource scheduling?
What's that?
Is it also true with resource scheduling? Does resource scheduling run native?
No, so DRS is ran on vCenter, and you won't be able to do things like vMotion then, right? But
Your vCenter does.
yeah, workloads won't go down, so it's vCenter to me isn't as mission critical as some people play it out to be, because if it were to go down, I could be fine with a 3 or 4 hour outage while I try to bring it back up. Yeah, it's not going to impact.
Provided that it's set up properly to begin with, and they set clusters. HA won't work out of the box without wrap around it first. But then it's all right.
Distributed switches.
Distributed switches will still run.
Right, they'll still run.
The policies will still be enforced, but obviously you can't manage the switch.
Right.
That brings up another conversation.
Yeah, about the distributed vSwitches, your design is very important. You have to make sure your management is outside of the distributed vSwitch.
Any comment?
I was curious about the disaster recovery that everybody's running, if they're splitting off all their single sign-on with their vCenter server, or if everybody's running them as one server.
I would tend to believe it's based on scale. So if you have a larger vCenter infrastructure, a lot of VMs, a lot of hosts, you'd want to split off those services just so you can give things like the inventory service as much horsepower as possible. Anyone out there splitting their vCenter services across multiple servers?
Well,
And for scale
so
reasons?
set where database, vCenter, single sign-on, vShield.
For scale concerns?
How many virtual servers are you using?
Virtual servers? 1,500, something like that.
So lab manager environment.
All right, everybody, we're going to kick off again. Happy to kick it over to Kyle to introduce Mark Davis from Versto and our next subject of software-defined storage. Kyle?
Great. Thank you, Rick. Thank you, everyone, for coming back from the break. I know you had distracted with coffee and water and shopping break. So thanks for coming back. And I look forward to catching up with some of you guys at the VMwares as well. As Rick said, my name is Kyle Murley. I was one of the first Oak for vSphere customers back in 2011. Did a beta and we put that thing into production. Very, very neat technology. Mark Davis is CEO at Bristow. Very intelligent team working on this technology, ahead of the curve, getting it out there, and that's one of the reasons that VMware picked it up. About a month ago, yeah. So all that's being integrated in with VMware right now. Mark is going to cover kind of the high levels, taking off from where Rick put us as far as what is software-defined storage, how does that fit into the overall stack, and that key pillar, and then we'll do a little bit of a deep dive discussion on under the covers, what's really going on there, how does it work. Further, I'll pass it over to Mark. Thank you, Kyle. So it's nice to be here. I think Rick did a nice job setting up what's happening in data centers overall. I'm a storage guy. I've been doing data centers for 20-some odd years, and so I'm going to talk all about storage. Don't ask me any networking questions, and don't really ask me any of these from future. I know enough about SDKs. But I can talk about the storage piece of the software-defined data center and what's happening. And what
Can you speak up, please?
A little bit louder. I would be glad to. Thank you. So, you guys keep interrupting me. What I'm going to do is I'm going to talk a little bit about the vision of the storage piece of the software-defined data center, and talk about why that made sense because of that vision and the connection that we had with VMware, why that made sense to put the two companies together. I'm going to talk about also a little bit about the point of software-defined storage, what the value propositions of these ought to be. And then for those of you who are really interested in details, I will go through some under the covers how the Bristow product works. There's other ways to do software-defined storage. I'm going to talk about the technologies my company developed. As Kyle said, I was one of the founders of Bristow, and was until about a month ago CEO of the company, and we were purchased by VMware in February. So I'm going to talk. Well, notice my slides, half of them will have the Bristow logo on it, and half of them have the VMware logo. We haven't got integrating a merger is hard. Integrating PowerPoints is harder, so we're still not quite done on that part, but we will. At least the content's mostly right. I would like you guys to guide me how deep and technical versus how high level you want me to be. So if I'm getting boring with the high level stuff, just yell out your board and I'll go to the next slide. And if you want me to go at least deeper on the Bristow stuff, I can probably if you want to go. Okay? All right. So just really quickly about Bristow, the company. This is Bristow as of a month ago, and I'll talk about what we're doing now as part of VMware. We started working on this project in 2007. And by the way, to give you a little background on myself, I've been doing storage virtualization since before VMware was founded. Storage virtualization is at least as old as server virtualization. There's been many, many approaches to it for lots of different reasons. The reason we started our company in 2007 was we talked to a lot of customers, including some of them based in San Diego, who were big VMware shops back in the day, and they all told us how much they loved what VMware did for their data center and what a total pain in the neck storage was inside of a VMware environment. And we heard that from everybody we talked to. So us being incredibly bright people said, aha, there's an opportunity to build a company here. So that's why we started our company. We are very, and have always been, very focused on the virtualized data center. Our software makes a presumption of a hypervisor abstracting resources. Without a hypervisor, our software is not particularly interesting. It works, but it's not particularly interesting. We are big believers in virtualizing data centers, and we have been for a long time huge fans of what VMware and Zen and KVM and Hyper-V have done to abstract compute resources. But we also have believed that we need to have the same kind of technologies and the same kind of abstraction and solution delivered to the storage world, and that's what Bristow is all about. And that's what we've been at for about 5 years. We were before we got acquired, pretty small company. Kyle Murley was our first beta site, and I think first paying customer, at least on the VMware platform. On the VMware. We also have had a product for Microsoft Hyper-V. Most of our customers were on the Microsoft platform until about a year ago when we fully released the product on VMware. Most of our customers today are running on the VMware platform, and certainly our customer momentum was because one thing I know is that people who run a lot of VMware understand the challenges of doing storage efficiently in that environment. So we don't have to. It's not very hard to find people who want to talk to us about solving those problems. We were a pretty small company. We're about 50 people, mostly developers. We're a very technology-oriented company. We're based in Silicon Valley in Sunnyvale. We had another team in Australia that was also part of our R&D team. Those two teams have been put inside of VMware as of about a month ago, and are working on two things. I don't have any slides in here, by the way, about product roadmap. I will tell you some things that I can tell you, and things I can't tell you I won't tell you. But I will describe at least a little bit, and if you have questions about where VMware is taking the technology and how it's going to apply in the future, I'm happy to give you whatever answer I can give you. So, one thing that's happening right now is we have basically two major thrusts where the technology is going to go inside of VMware. One of them is to continue to develop the Versto product that I'm going to talk about today as is, except for better integration, more performance, more features, the usual things. The second thing is there are some future technologies that we were working on and that VMware were working on before we put the two companies together. So we've got a team of people that are dispatched to work on stuff that I can't tell you about, that won't ship for a little while, but it's pretty interesting stuff. And it certainly is all about driving a proper software abstraction for all storage hardware resources in data centers. Again, I'll talk about that a little bit more. But that's where the engineering team has gone to work inside of VMware. The rest of the company is out helping integrate the technology into customer environments, get more and more happy customers using the Versto technology today. Then we'll be launching and announcing more stuff at VMware in the fall. So that was VMware as an independent company. Pretty good team of people from all over. This is a slide you've probably seen. I don't know if Rick showed in the previous slide. This is a slide I stole from VMware about a year ago. Everybody wants to talk about the software-defined data center and how do we properly abstract all the resources. And I do think that we've done such a good job on the compute side. There's still work to be done, but we're pretty good at it now. There aren't dramatic, massive shortfalls in virtualization compute resources today. There's things to work on, but it's mostly pretty well done. Networking is not that well done. It's getting there. And certainly what VMware has done, what Cisco has done, there's quite a few startups doing still software-defined networking. VMware obviously made a pretty big statement last July when they bought Nicira for $1.26 billion. It's a very, very interesting space that's moving pretty fast. I think 5 years from now, the networking industry is going to look very, very, very different. I think the nature of how we do networking in data centers is going to be fundamentally different, and we're all going to be sitting here 5 years from now to be much saying, remember when we used to talk to switch hardware, we actually used to configure switches and routers and things like that? It will seem as sort of prosaic and kind of cute memories from the past as remember the days when we all used to boot our Solaris servers and deal with physical hardware on the server side. The same thing is going to happen to the storage industry as well, which is where Versto fits. And our view at Versto was always that the weakest link in this software-defined data center was storage. It was the part that was least well solved, and for the most part, there hadn't been a lot of innovation. There are a lot of people doing things that they would call software-defined storage or storage virtualization. Most of them, in my opinion, are not terribly innovative. They are applying technologies that were not designed for this problem space and trying to sort of hack them to make them work in a new problem space. And while that's useful, we always had a different point of view. At Versto, we believed that you needed to build a technology from scratch for a virtualized abstracted data center. And we certainly think we've done innovative things. There are some other companies that are doing some pretty innovative things. VMware on its own, before acquiring Versto, also has some pretty interesting things in their roadmap, some of which they've talked about publicly. So we've talked about vVols, we've talked about vSAN a little bit. We talked about that at VMworld last year. Still, that's still hasn't been described in detail. It will be relatively soon, or at least sooner, or at least the first version of vSAN will be talked about publicly at VMworld in the fall. But we still got a lot of work to do on the storage front. This is why it made a lot of sense for VMware and Versto to hook up. So we started having conversations together last fall because we all realized that there is an industry that is in dire need, not because the industry needs it, because people who are customers need it. This is an industry that really needs to be completely transformed. Would you guys build a data center? By the way, I grew up with Sun Microsystems. Would you build data centers today if you still had to do everything on Spark Solaris? I mean, you just couldn't build the data centers you're building today if that was the technology you had, and PA risk systems and, you know, all the other stuff that we used to build our data centers out of. You had to build them that way. You simply couldn't do what you do today. And it was what VMware, as the point company driving server virtualization, it was that transformation that's allowed us to do things in data centers that we scarcely could have imagined doing before. We need to do the same thing to the storage industry and to the networking industry, so that people can do things with the other 2/3 of their data center with the same level of creativity. And this is what makes it a very, very large opportunity for VMware as a company and for any other company who is participating in this marketplace. But it will fundamentally transform. The magic of what VMware did with compute virtualization was completely changing the way servers are built, completely changing the way they're deployed, but still all the software still works, right? By providing that sort of instruction set compatible hardware abstraction that looked like a server, it allows us to sort of do things the old way, but under the covers at the infrastructure level, do them completely differently. We need to do the same thing with networking and with storage, and that's certainly what we're about here. And that's why the Bursto vision and the VMware vision for the software-defined storage part of the software-defined data center hit so well. When we started talking with VMware, and we've known the VMware team since certainly before we founded our company, we started getting pretty heavy technical conversations with VMware over the last year. It was surprising how similar our visions were, and not only how similar our visions were, but how our software was actually architected very, very, at the very lowest levels. And the reason why it made a lot of sense for us to put the companies together was that we were moving on the same vision. We had some things to offer to VMware that VMware could have built themselves, but would have taken them a long time, years. And likewise, there are things that VMware had worked on that were part of our vision that would allow us to get to market faster with what we wanted to do. We do believe that there's a fundamental shift. I mean, a really, really fundamental shift. It doesn't mean storage hardware becomes unimportant any more than VMware Compute made server hardware unimportant, but it will change the nature of competition in the industry. It will change where the value proposition is, and it will move to software. And it will move to software that doesn't require a specific brand of hardware underneath. And that's actually a very positive thing and a very exciting thing, I think, for everybody in the industry. I don't talk to any customers who don't want this to happen. When I ask a customer, would you like to have your storage be abstracted the same way your compute was, nobody ever says no. Now, there's lots of hard questions about how you get there, but everybody else can go there. So, what I'm pleased by when we were, again, thinking about whether or not putting these companies together was the degree of aggressive vision that VMware has on this front. There's a lot of work to do, I can tell you, and I wish I could say at VMware this fall we're going to launch everything that is a solution to all the problems there are to be solved in storage. It will take years to get everything done that we can see today. But the vision is very strong, and there's a strong belief that we need to be a company that is driving the revolution, that is doing with storage what VMware has done for the server. So that was the driving impetus for why we put the companies together. That's what we're trying to achieve, at least at a high level. And we're excited now to be part of VMware and trying to make this thing real. It's a lot of work. VMware has lots of storage engineers. There are 300 software engineers inside of VMware that do nothing but storage. Before they added my giant 25-person team to it. So there's a lot of effort. VMware itself as a company has for a long time had a lot of storage technology to bring to bear. Obviously, VMware as a company works with lots and lots of storage vendors in a lot of ways. The level of agreement between VMware and its partner community about this revolution also is frankly very confusing. When VMware started a long time ago, server vendors hated VMware, and I mean hated VMware, because they were very threatened by VMware. And it took a while before the server vendors started being partners instead of enemies. I'm pleased to say, at least so far, it looks like that on the storage side, we're going to have a lot more partnership. We're not going to have to go through that 3 or 4 years of hating each other before we try to love each other. So working on this problem can be, if we work hard together, we can get there really fast. A few years to get to where we want to go. Okay? That's kind of an overview of kind of super high-level vision. You guys okay with that? All right. So now I'm going to talk a little bit more specifically about what the value proposition ought to be. What I'm going to show you is all verse of specific stuff because that's the material I have. But it doesn't necessarily mean other people can do this. Other people can solve the problem in different ways. But I'm going to talk about what I think software-defined storage ought to deliver to you as a customer. Okay. So this is a VMware slide. I've noticed that people at VMware like the blue slides with lots of words on them. So I will not read the slide to you, but we all know what virtualization did for our compute. So I'm just going to click through this. Yeah, we move things around. We've got a lot of mobility. What we do is we've enabled new problems to creep up. That's what new technologies do, right? It creates new problems. And specifically on the storage side, the nature of having all these servers, these virtual servers that we do today, makes management of the storage that's attached to that so much more complicated. So these are various and sundry quotes from different VMware users. It is amazing how inefficient we do storage in virtual machine environments. It's stunning. And I would be willing to bet any of you who are running a data center who think you're running it efficiently, if you're probably just mismeasuring. It's probably not as efficient as you think it is. It is so tragically inefficient, the way storage works today. It's way the heck better than it was a few years ago. When we started our company in 2007, it was a disaster. It's getting pretty good now, but we've got a long way to go before we get to the level of simplicity, efficiency, and low cost that we ought to have in the storage world. The vast majority of disk drives that have ever been shipped in the history of mankind were unnecessary. Way more than half of them. Probably more like 80% of the disk drives that have ever been built should not have been built because nobody really needed them. But we bought them because we needed more spindles, or we thought we needed capacity we were never really going to use, or whatever. A great deal of the iron oxide that is on disk drives has never been written to, ever, and probably will never get written to. It's just amazing how inefficiently we use storage. It's getting a lot better these days. We got a long way to go. And there's other problems, of course. The side effect of things being inefficient is we spend too much money on it. That's certainly the way we used to in the olden days of data centers. If we have enough compute power, we put another E10,000. We kept doing that until the problem went away. And it's okay that those things cost $1 million a piece if you worked where I worked in some microsystems, but if you worked where you worked, $1 million per server got pretty old pretty fast. So we do have, for lots of reasons, we end up spending too much money because we have inefficient use of capacity. We do still have this problem that data services are associated with a LUN in many cases, and not with the VMDK, which is totally crazy. If you run a virtual machine environment, you should not even know what LUN stands for. It's completely irrelevant to you. If you are a storage person in a VMware world, the only thing you should ever have to think about is the VMDK, because that's what storage is to you. And there are some great technologies that are coming. The vVol technology that was done with VMware and its partners is going to do a lot to solve that problem, to allow the storage hardware vendors to present services basically at the VMDK level. That's a lot of technology that was talked about publicly at the last VMworld, and we'll talk about more at the next one. Every device needing its own management tool, again, is just insanity. It's not that we don't need endpoint management things. We need them for servers still. We still have, Dell still makes, hardware management tools that will tell you how fast your fans are running and things like that. But we really need to have as much abstraction. As Rick was saying, we have to abstract things out so that we are not worried about what's happening in the underlying hardware. And there is this other problem that has become more recently critical. What's happening with flash-based storage, which is usually in the form factor of a solid-state disk, but more and more is going to become in the form factor of solid-state memory that may look like a disk or it may look like memory that's inside of the server. Today it's on a flash card. It will be soldered to the motherboard in servers not too long from now, if it's not already. This new technology that's available to us, and the fact that we can still put lots and lots of rotating disks that are super cheap inside of servers, has a whole bunch of customers asking, why can't I use that for my storage? Well, today you can't use that in any virtualized environment because you lose mobility of the virtual machines. And you lose some of the ability to aggregate performance and aggregate data service features through shared storage. But it sure would be nice if we could take the storage resources that are inside of our servers, which are pretty powerful. And by the way, if you do the math, it costs a lot less per gigabyte than the storage that's in the disk array that's attached to that server. If we could use that efficiently, then we could deliver much, much better services to our clients at much lower cost. So this new kind of technology where we're not only just doing flash, but we're putting it in the server, is going to create a huge amount of demand for people to solve that problem, for how we can make those resources behave as if they were externally shared storage with all the redundancy and high availability features associated with it, but still was very inexpensive and super high performance because it's very close to the CPU storage. So at first off, this was always our slide. This is what the problem is. In a lot fewer words, we take a whole bunch of virtual machines, many thousands of virtual machines. We run them through a hypervisor. So the hypervisor layer in each server takes all the workloads from all the virtual machines, takes all the I/O load and just shoves it, first in, first out, shoves the I/O down to the disk subsystem, and the shared disk subsystem on the other end is presented an incredibly jumbled mess of I/O requests that is highly, highly randomized, and particularly, which any storage system doesn't like, but particularly storage systems that have rotating media don't like. And so storage vendors have been struggling to find ways through better caching, more clever tiering, putting certain solid state in front of the rotating disk, have been struggling with trying to solve that problem, which is great. But we also could solve that problem by avoiding it in the first place. It would be nice if we could order the I/Os much more efficiently before we ever ship them to the disk subsystem, which is one of the things that personal software does. We also waste an enormous amount of capacity for all kinds of reasons. Virtual machine world is particularly bad at using storage hardware. It's particularly bad because of the way virtual machines work. One of the things that really, really changed when we moved from physical computing to virtual computing was that what the server was changed from being a physical object into being a piece of software. And in fact, to being a big file. Because that's really all a virtual machine is. It's just a big file that happens to, when you attach it to a hypervisor, behave as if it were a computer. That's all VMDK really is. It's a big file that is capable of emulating what a computer is. That's a wonderful thing, and that's the reason why virtualization is so powerful, is that the magic of that abstraction. But it also means that when we make a new virtual machine, we make another file. You can't make a virtual machine without provisioning storage. The act of making a virtual machine is a storage provisioning operation inherently. And it's generally a very inefficient one. What we do is we go make a copy of that file to go make a new virtual machine, which is just crazy. There's no reason to copy that file every time you want to make a new virtual machine. You ought to be able to just say, make me another virtual machine that's just like that, take a snapshot of that, and only create new bits that are unique to that virtual machine, and leave all the other 90+% of the data alone, because let's face it, if I've got 1,000 Windows virtual machines or 1,000 Linux virtual machines in my data center, most of the bits inside each of those virtual machines are exactly the same, and they will never change. Run an experiment sometime. Take Windows, run it through a year's worth of patches, and then do a diff from what it was previous year. Still, 80% of those bits never change in that image. Yet we make copies of it over and over and over in our data center. So it would be really nice if we could have a way to make virtual machines where we never replicate data we didn't have. Right? And this notion is one that a lot of companies have tried to figure out ways to solve. We have our own particular view of how we solve that. And we still do have management systems that require the vSphere administrator to either themselves know way too much about storage, or to spend too much time talking to their storage administration. There should really never have to be, or rarely have to be, a conversation between the storage admins and the server admins. But today there's way too much interaction between those two people. And it makes the process of not only provisioning, but ongoing performance management, very, very tedious and complex, and an unpleasant process for everyone. I don't know any storage admins who like their server admins and vice versa. It's pretty, there's lots of reasons why there's inherent contention, right? Just like olden days of DBAs and server admins never like each other either, because they have different sets of problems they're trying to solve. And neither side really understands the other one's role very well. So, what we build at Bristow, let me give a little bit of a pitch for Bristow, is we build a piece of software. It is just software. We don't care what hardware is underneath. The hardware compatibility list for Bristow software is whatever VMware runs on, period. That's it. The way our software abstracts inside of the virtual machine layer, we don't care what the underlying storage is. It can be any kind of storage. As long as we can talk to it as a block device, we can speak to it. It can be fiber channel, it can be iSCSI, it can be SAS, it can be SATA, it could be a thumb drive, it could be anything. We have a pure software abstraction that does create the virtual machine as the center of the universe. We are big believers that the VMDK is the center of the storage universe and the data center of the future. And so everything is about the VMDK. It does optimize performance and reduce cost. We'll talk about that. And the greater agility, I think, Kyle, is one thing when we first met up with Kyle, he really latched onto was the fact that you can have much more flexibility to move things around without having to be an expert in storage or to have the right kind of disk array that has that kind of feature in it was a big value proposition that a lot of people latched onto. So we have some customers. Our first customer, Microsoft, listed on this slide, probably won't be our customer anymore. I'm guessing because Microsoft and VMware are not always the best of friends when it comes to virtualization. Microsoft actually does use our software in their games division to run workloads. I'm not going to go through this slide in detail. There's San Diego State University. The point is that what we are able to help customers with is by adding a layer of software that we refer to as a storage hypervisor into the server hypervisor and manage the I/O load more efficiently. We can, across a range of workloads and across a range of different kinds of storage hardware. And by the way, every single customer here that I'm aware of, I'm not sure about you, Kyle, but these people all have solid state as part of their storage tiering. So there's some solid state, some rotating, and all these configurations. In all cases, end up with some pretty spectacular performance boosts and some dramatic reductions in storage capacity requirements. At the same time, have a solution that provisions up storage very, very quickly so that you don't have to spend all your life preparing your storage for your virtual machine environment.
Excuse me.
Yes, question.
Did you just say SSD is required?
I did not say that. I said that in this quick, all these examples, there happen to be SSD. These were all mixed. I don't think any of these were pure solid state. Most of them were, a little bit of solid state and a bunch of rotating. Our software, again, if it looks like a lung, we can talk to it. So it's just as simple as that. So we do not require solid state. We love solid state. It's a lovely thing. I can talk to you when we get into the architecture a little bit, kind of where solid state is particularly useful with the Bristow software technology. But we certainly don't require it. Okay, so what's our software good for? This is the last marketing slide I want to show you. Okay, lots of workloads. Basically, the stuff you would virtualize. Test and development is a great workload for what we do because one of the things our software is really, really good at is we can make stupidly large numbers of snapshots and clones. And by stupidly large, I mean tens of thousands without breaking a sweat. We actually can probably do hundreds of thousands breaking a sweat. We just don't have any customers that big. Where might you want to do that? Well, test and dev, where you're constantly making gobs of virtual machines and running them all, running them all day, and then you tear them all down at the end of the day and start again, for the next build, stuff like that. That's a really good use case for that. Virtual desktops is a really good use case for data services where you're not replicating that virtual machine image every time you make one. You get very, very space-efficient cloning technology, but wanting to fire up lots and lots of them very, very quickly. So these are particularly good use cases for what we do. Database virtualization also, where particularly if you're in a test and dev environment in database where you're doing internal development on Word or SQL, constantly having to go from development to QA to pre-prod to final QA testing before you go into production. The numbers of copies we all make of databases is also crazy, and virtualization just makes it crazier because it's so easy to make copies of things in virtualization. So these happen to be the best sort of use cases for the Bristow software. So we all know why this. Does everybody know about the term virtual machine I/O blender? Not everybody. So we've been talking about this for 5 years, so I just assume everybody knows all about it. So what happens? So at a high level, what happens when you have lots of virtual machines running? Each virtual machine generates a load. Each virtual machine thinks it owns hardware. That's what hypervisors do. They lie to operating systems. They tell the operating system that they own hardware that does not exist. Right? That's the beauty of it. So every virtual machine thinks it's optimizing its storage load, for the HBA and for the underlying storage and managing the queue depths and the elevator algorithms and all this kind of stuff. The problem is I've got 50 of those running on one box, all 50 of those workloads, which have been sub-optimized by each operating system, then get munged together and multiplexed through the hypervisor, which has no choice but to service the IOs as they come. Can't reorder them. That's against the rules of storage. We have to do IOs in the order requested. That's the semantics of storage IO, right, that we can't break. So what you end up with is, after I've taken all these workloads and multiplexed them together per server, and then I take a bunch of servers and aim them all down in a disk array, what the disk array sees is an incredibly random IO stream that it has to try to figure out some way to reorder and clean up. Because if it really had to go do every IO, you're going to go do this one that's over here on this disk drive, I'm going to go do this one that's over on this disk drive, and every time I've got to wait for an arm to move and a platter to rotate, it would take all day long to do the I/O, and we can't have that. So disk arrays have some very clever algorithms to try to take all this stuff through their caches, reorder things, put them in caches and non-volatile caches so the writes can be acknowledged earlier. But it's a big problem, and it's a problem that's hard to solve at the hardware level, and it's a completely unnecessary problem. This problem is completely solvable. We could reorder the I/Os before we send them down to disk array, which is really what we do. So that is what we call the virtual machine I/O blender, a term we didn't make up, but we stole 5 years ago from other people, and everybody talks about it. This is the fundamental storage performance problem that virtualization uniquely causes. We didn't have this problem with physical computers because every operating system really did own its own hardware, and it was making good optimization decisions. And of course, how do we solve the problem with the I/O blender? Buy more hardware. We throw more spindles at it, we short stroke, we buy bigger caches, we buy more SSDs than we probably needed, but we do anyway because we had to get performance in. VDI makes the problem worse. Any of you guys who've done VDI, VDI is just like regular virtual computing, it's just more painful. But particularly with respect to storage, it just makes the problem bigger. Why? Because I'm not running 20 virtual machines per server. I might be running 50 or 80 or 100 or 200 on big servers today. We know customers that are running a couple hundred virtual desktops per server. That I/O blender effect just gets worse, and it is a geometrically growing problem. So twice as many servers is a lot more than twice as much randomicity in the I/O. So, and virtual machines have much more variability, right? There's times of days when virtual machines are really, really, really busy and generate a huge amount of I/O load, and most of the day they're sitting relatively idle. So when you're building the infrastructure, you have to optimize around solving that one part of the day when everybody comes to work and logs in, and most of the day you're over-provisioned, and it'd be nice if we didn't have to do that. So I'm going to give you a couple of mildly geeky performance charts here, which I hope you can follow along with. The top left graph here shows, with native snapshots, this is actually on ESX, this is the ESX5, showing the bars, the blue, red, and yellow, and green bars are IOs per second, and the lines that are swooping up and to the right there is latency. And this is showing what happens as you add snapshots to a VMDK. One VMDK, pretty damn fast, and latency is really low. You add one snapshot, and performance degrades a lot, by more than 50%. Add a second snapshot, it degrades even more. You can sort of see there's a nice little asymptotic line that doesn't ever quite go to zero, but performance gets pretty bad pretty fast. Which is too bad, because snapshots are really a great idea in virtual machine environments. Because, again, we've got so much duplicated data. It'd be nice if we could run our virtual machines off of snapshots, but we don't because of this graph. And most people know that if I want to do space-efficient snapshots for my production virtual machines, I'm either going to have to do a lot of hardware as a problem, or I'm going to have to be okay with performance being bad. For most people, that second thing isn't an option. You can't tell your users, well, the good news is I saved a whole bunch of money on storage. The bad news is your apps are slow. You aren't allowed to say that, right? So what we do is we don't use snapshots. So instead, we replicate all this data. Every time we make a virtual machine, we make another copy of Windows. God knows we all need one more copy of Windows in our data center. And we waste that space. That's the world of sort of native snapshots. This, by the way, is on a VNX, which model of VNX. This testing was actually done between EMC and Versto. The right test here shows what happens as you add snapshots in a Versto world. So you can see with no snapshots, performance is basically the same. And we do have some degradation, so as we add snapshots, we do lose some I/O performance, but what you don't see is the level of degradation, and you also don't see what happens, frankly, completely unacceptable response time. Having a pretty flat response time and being able to sustain a lot more I/O load as you add lots of snapshots allows you to utilize the hardware more efficiently, because you can optimize around, assuming this flat line, that's more like at a much higher level than you would have if you were using just a native snapshot in facilities. This making sense? Too geeky, not geeky enough? All right. So I'll tell you what this means. I'm going to give this a customer example. This is one of our largest customers. In fact, this was Versto's largest customer. It was a software development company, publicly traded, not Microsoft. So this particular customer had a lot of the problems I just described in performance. To get the performance they need, this customer runs 1.5 billion SQL Server transactions a day, which is kind of a lot. 300 physical servers running SQL Server. Their challenge was huge data ingest. They basically got a big data analytics problem that they deal with every day. They ingest all this data from millions of points around the world every day, and then they have to run analytics on it basically constantly. So they've got gobs and gobs of analytic apps that run on this data as it comes in. The problem they were facing was, how do I ingest all this data? How do I run the analytics and do it in a way so that my storage cost does not grow at the same rate that my number of transactions grows? That's called a non-scalable business, and nobody wants to have that happen. So their challenge was the storage budget that they were looking at was just so out of control that they didn't know how to solve the business problem of being able to do all these analytics, which are the fundamental revenue generator for this company. And at the same time, have the storage budget not become an incredibly large percentage of the company. What we did with Versto was we showed them how they could save a whole bunch of money on storage hardware. They still got to buy storage hardware, and they still buy plenty of it. This happens to be a Dell Logic shop. Dell Compelling shop. But they were able to buy a whole bunch less. And yes, we charge them a pretty large amount of money for our software too. We don't give our stuff away. But net, they ended up saving a whole bunch of money. But more importantly, you end up with something that long-term is scalable, so you don't have this every time I need another 100 terabytes of storage, I've got to go buy another 100 terabytes of storage. There's got to be a way to have your business problem double without having a double amount of hardware you put behind it. And that's, again, one of the things that virtualization has done for us over the years, and we've got the same thing on the storage side. This is just one sort of example of the financial impact. Here's one more. This is another one of my favorites, but again, maybe too geeky. This was another test we actually did jointly with the VNX group at EMC, the VNX team in Hopkinton. A couple of things to see about this chart is on the left side is kind of standard way we would all do this stuff without Versto, showing what happens over time as the workload changes. This is a Microsoft SQL application. And what you'll note is that pretty spiky, as different workloads are applied, we actually were running this through a series of different workloads. As different workloads get applied, which is what happens in the real world all day long in our data centers, response time and I/O throughput vary pretty dramatically with the native kind of built-in storage features that come with the hypervisor. When we added the Versto software to the problem, what we found was we were able to just generate more throughput, about double, a little over double the IOs per second throughput, considerably better response time, and more importantly, consistency response times. Because if you're designing a data center, you always have to design for the worst case. It doesn't matter if your software, if your application runs great 90% of the time. You have to sort of design for that worst case peak. And having a system that gives you consistent throughput, irrespective of the load, is something means you can plan around, getting a lot closer to the threshold of the hardware usual. So, and the funny thing is, we do this by adding software. One of the sort of interesting ironies is we tell people we're going to take all the stuff you're running and we're going to add software to it. We're going to make it go faster, which is completely nonsensical. And people's first reaction to that is that can't be possible. But of course, we can. We can get more throughput through things with the right kind of software that's effective. Okay? All right. That's sort of high level kind of what we can do, why we ought to do it, and what the value proposition is. Any questions about that? Because next I'm going to go in, what I'm planning to do is go into the internal guts of the way our software works, how it plugs in, and what it's worth. As Kyle and I were saying earlier, this is stuff you should never have to know. It's like, none of us should really know how a chip works or how an operating system works, but we're all curious, so we like to talk about it and understand it. So I was going to do that if that's interesting to you guys. Do you have a question?
Just a general question. Is this going to stay a separate product with VMware for a while, or is it going to get rolled into something else?
Yeah, so the question is, for everybody is the Versto product going to remain a separate product, or is it going to get rolled in? So it will remain a separate product. Today, as you guys know, when you buy ESX, or you buy the larger VMware suite of solutions, there are a whole bunch of software technologies, including storage technologies, that come with it. When you buy Enterprise and Enterprise Plus, you get different kinds of features. And that's the way you pay for storage software features, if you will, is by buying different licensing deal from VMware. What we're trying to do at VMware is build a successful disruption of the storage industry for the benefit of end users. And to do that, we need to fund the business. To do that, we can't give away software. So our goal is to, just like we have on the compute side, make it where it's incredibly financially efficient for you to spend money buying VMware software, even though that, again, just adds to your total cost. You're already paying for operating systems, you're already paying for server hardware, and now you got to buy a hypervisor on top of it. But we all do that because we add up all the math, and it still comes out way cheaper. So that's what we're trying to do on the storage front as well. So we will charge for the software, and that's not temporary. That will be from here forward. This is not the end of the Versto product roadmap. There are other things that will come out, and there are other kinds of ancillary technologies that the Versto technology will go into. But there is not, you shouldn't have an expectation that in vSphere 6 this stuff just will come, sort of get rolled in. It will be better integrated. There's lots of ways now that we're inside of VMware we can integrate the technologies much more elegantly. Being an outsider and using only the publicly available APIs, I can tell you, is somewhat painful to build an integrated solution. The VMware APIs are okay, but they are not perfect, and I assure you do not work as advertised. So, and that's normal. So being on the inside now, we can deliver a much better integrated solution because we can be inside the VMware kernel. My engineers loved it their first day after we got acquired, and they got to look at the VMware source tree like, oh man, if only I'd known I could do this. So there will be much better integration from that point of view, but from a packaging and pricing and how you get the software, it will remain a separate product line. And this, without getting too terribly specific, the Versto product, again, so you can buy it today. We'd be happy to talk if you've got storage problems. So I guess what we do is we'd love to talk to you about today how you can use it. We can certainly talk under NDA a little bit about where the roadmap is going. But the Versto technology will both live on as a separate product, which is today implemented as a virtual storage appliance on ESX. That product will have a very long-term life, but there are other things, some of which VMware has talked about publicly, one of which in particular is vSAN, where the Versto technology will play a big role. That will ship in the future, but that will also end up being sort of a separate product line from the vCenter suite of things, right? Which, by the way, is the same thing. In case you would ask, same thing on what VMware is doing on the networking side. There are certain networking, virtual networking features that are built into the vCenter suite, but there's also certain pieces that will be separate product lines. And the reason for doing that is different set of competitors, different set of solutions, different set of buyers oftentimes in the data center. So, they'll remain kind of as separate. Yes, sir.
So getting the basic concept without going into the depths of what you're probably going to cover here. So if you implement this, I'm imagining there's going to be quite a period of time in which all this magic happens. So you implement it, it's basically doing a massive deduplication and defragmentation of your entire SAN. What are you looking at? What are you looking at that's going to have an impact on your storage, that's going to have a time,
Yeah, so one way to think about the Verso software is think of it as a parallel alternative to VMFS, architectural. So whereas VMFS makes data stores and you create VMDKs out of that data store, you sort of do the same thing with the Verso stuff. So think of, I've got my core hypervisor here, I've got VMFS, I've got another thing called NFS, which is another way I can connect storage into VMware, and then I've got Verso as a third alternative. It operates at the same level architecturally. So what that means is, if I've got a running data center, and I want to add Verso to it, I can add it in as sort of as a parallel file system. And if I want to have my existing virtual machines take advantage of the Verso technology, I'm going to storage vMotion them from the VMFS data store over to the Verso thing. And that will take however long it takes, but it could be a while. Right, so part of, so an implementation of this, if you're going to want to envelop and engulf and take over the existing VMDKs and move them over from standard VMFS, you will want to, you don't want to do it all at once unless you have way too much storage hardware around, which you might, a lot of customers do. But you're probably going to want to sort of stage that out in space, and it could take weeks to move things over depending on the size.
That's more easily defined roadmap for saying it.
Yeah, so it is, again, this thing has to look like a regular storage thing. Right? That's just like, a virtual machine has to look like a physical machine. To an operating system, we have to do the same thing. So the normal things we do with storage in a VMware environment, including things like storage vMotion, do work on this. So, once you install this, you install the Verso stuff, you can just, and you don't have to, by the way, you can have VMFS and Verso running on the same machine at the same time. No problem with that. And you can choose to migrate or not when you want. Yes, sir.
A couple questions. When you actually install the Verso and then is there limitations on which hardware vendors you can work with, which SANs are compatible with it?
Yes, so the first question was, where does it install? So I'm going to give you the answer for the way the product ships today. It will change in the future now that we're part of VMware and we don't have to do things as an outsider. Today, we install as a virtual machine, basically. So our software itself is a virtual machine. Okay. So it sort of looks like, and you install one per host. Okay. Okay. There's one instance of the Verso software per ESX host. And then there's also a management system, just like would have vCenter as a separate management server in a VMware environment. We have our own separate management server as well that you would run usually under VMware HA because you want it to be a highly available service. So there's one instance of that per data center. Okay, does that make sense? And your other question was hardware compatibility. Yes. So again, people just don't believe me when I tell this, but it really is true. It looks like a LUN. Our software talks to it, and we've never ever not had that work. So what we can't talk to is NFS. We can't have an NFS target on the other side. But if it looks like a disk volume to ESX, we talk to it. And what we do, what the Verso software does is again, you would just configure the storage as raw, and then our and then our software sort of takes over the management control, and we manage data layout. We manage the flow of I/O through the system in a way that's transparent to the underlying storage. The storage hardware doesn't need to know anything about us. Again, it's just going to see SCSI reads and writes like it always has. Guest operating systems are also unaffected. We don't put a single bit of software in a guest. Again, whatever guest you run, I promise you will run with our storage. And it's because of where our software sits in the stack. Our software doesn't even know if it's talking to iSCSI or Fiber Channel. That's why it works. Is we're sort of a higher level abstraction of simply looking at, If it's a piece of storage that's block addressable on 512 byte block boundaries, we can talk about it. So the hardware is whatever hardware works on ESX, but it needs to be blocked. And we have customers using VNX, just you name the kind of storage from a branded vendor, and we have a whole bunch of customers using storage. I don't know where the hell they got it. Don't know what brand it was, came from who knows where, and the software won't work. Yeah.
So in regards to that, then if you're using with that setup, would you still want to use, say, native snapshots on that hardware device, or would you kind of not use any of that, or would you use your software for that kind of activity?
Right. So the question was, okay, if I've got a disk array that does snapshots, now you've got your thing that does snapshots, which one do I use?
Right.
So the answer is, so you already have to answer that question with native VMFS too, right? Because VMFS snapshots, your storage array has snapshots, you have to decide which one to use. vVols will, by the way, reduce the importance of the question that you're asking, eventually, because vVols will make it where native snapshots in the array can be managed as VMDK snapshots. The answer is you can do either or both. There's nothing stopping you from doing snapshots at the array level and snapshots at the VMDK level up inside the hypervisor. They will work together, and some people do. And the answer to your question sort of depends on which array vendor you have, because snapshots work very, very differently from array vendor to array vendor. And frankly, within the same vendor and different product lines, they work dramatically differently also. Typically, array-based snapshots are based on the LUN. When you're snapping a LUN. Which, if you have one VMDK per LUN, is fine, but that's an unbelievable pain in the rear to manage, so hopefully nobody does it anymore. We try to stop doing that. So if you're just wanting to snapshot or clone a VMDK, it's probably more efficient to do it at the host level. One of the reasons we haven't done that in the past is because host-based snapshots and clones have their own problems. You will note them from my previous slides. We think we solve those problems by having the right software at the host level, so you can do per VMDK, snapshotting, cloning, those kinds of operations, without having to pay a performance penalty. And also, by the way, do it in a way that's very simple and integrated into vCenter is just kind of a normal operation. But if you have some reason why doing your snaps and clones at the LUN level make more sense to you, which sometimes it would, for example, in DR situations, where you're wanting to really sort of take a snap of a lot of things at once for DR purposes, that may make more sense in that situation. But that's a very long-winded sort of way of saying it depends.
One last question, sorry. So you have your virtual appliance that has the Versto software installed on each host.
That's right.
If something were to happen, like that were to be turned off, or worse, deleted, do you get totally screwed and all the VMs crash down, or what happens?
Yeah. So it's the same as if your device driver, your HBA driver fails. Okay. You can't talk to your storage anymore. So you want this service to stay up, and you want it to be highly available, which it is. Right. So our philosophy at Versto was always to leverage the underlying platform's underlying services as much as we could without recreating wheels. So what that means on VMware is the way you make that service highly available is we run it under VMware HI itself, just like you would any other virtual machine. So our software does support, staying highly available that way. But it is, it's just like what happens to your apps if your operating system dies? The apps die. So it's sort of the same. We are in the I/O path. We're absolutely controlling that, just like VMFS is. By the way, if VMFS dies, you also can't miss your data. If your HBA dies, there's lots of things there's lots of things in the I/O path you don't want to go down, and we're certainly on that list. We do things to make sure we're highly available, of course. And I could talk a lot about how you engineer software like this for mission-critical operations to make sure that it's very tight, very simple code. You do not want super complex code. Doing stuff like this, you want it to be incredibly elegantly designed, so you don't have too many billion code paths to go wrong. But yes, you want this to be highly available. Those are some of the things. Yes.
So what happens to VAAI?
What happens to VAAI? It keeps going. Right. So it's still quite useful. Look, there's lots of different ways to skin any particular cat. You're one of them. VMware thought so much of it, they wanted to be part of VMware, so now it becomes sort of the standard VMware product. I don't think we at VMware are going to say that you have to do it this way. There were other people that are doing, the various PAI, both the SAN and the NAS APIs are still useful for things. So, VMware is certainly not decommitting any of that stuff. From my point of view at Bristow, I was going to implement PAI NAS because that was the way I was going to solve some of my problems technically, but now I don't have to because I can get the kernel myself. So from my point of view, from my personal point of view, VII is a lot less important to me than it was a month ago. But I think, externally for any array vendors or other people, it's still quite relevant. And there's no decommit on the roadmap. Yes.
So I just want to make sure my understanding is correct. So your install is storage DSA,
yes,
and then it'll hook up the storage on one side, then present to vCenter as a different kind of data storage in parallel with your NFS and the VMFS.
That's right.
And in order for the VM to take advantage of the optimized storage I/O, all the VMs have to live on this particular.
Right.
And the existing VMs don't have any advantage because they are on their own VMS store.
Right.
So the way you optimize the I/O is by looking at all the VMs, randomized I/O, and then make it more optimized.
Yep.
When it comes to storage.
Yep.
So that's all correct.
Everything you said is correct.
So I just want to understand how it really
I'm going to show you some pictures here in a second. Might clear it up a little bit.
Okay.
Everything you said is right.
Okay. Then the other thing is for this thing to talk to the backend storage. If I have some HPA redundancy to have the multi I/O path, and what is the relationship in this software and the HPA?
There isn't much. So we do work in those environments. So the HPA redundancy feature, whether EMC has their own version, VMware has its own version, some of them have their own. All that stuff still works with our software. All below us in the IO stack. So if you're using those pieces of software to manage multi-pathing of HPAs or that kind of thing, all that stuff still works. Underneath us.
Okay.
And our software, again, our software doesn't know. Our software just sees LUNs. That's all we talk about. And how the LUNs get presented, through how many redundant HPA has, and all that stuff is up to the API drivers and API failover software and all that stuff, which still works perfectly well with our software. You don't lose anything. Yes.
So your value is you enable the customer to purchase less storage, less performance storage, and less storage management software. How does that fly with the company that owns the company that bought you? That seems like their whole revenue model.
So we're having beers this afternoon, I can give you a different answer, but I'll tell you that the answer. So I will say something here that is it's a great question, right? I mean, I'll start by saying, I don't know if you guys know this, but because of the ownership structure of VMware, the board of directors have to approve acquisitions of certain size, and that's certainly well above the minimum. Who is the board of directors of VMware? Tucci, EMC. They're all EMC people, almost all. In fact, all here. So this wouldn't happen without VMware's approval at the highest. Without EMC's approval at the highest level. So EMC is very behind it, is a short answer, right? So it's very, very short-sighted for any vendor to try to screw their customer over for too long by getting them to buy stuff that they don't need. We've done that in the computing industry for a very long time, and we always do it for as long as we can get away with it. But I think smart companies realize that the best way to build a long-term relationship with your customer and actually build a successful business is to give them the best possible solution. And if that means selling them less hardware, that's a good thing. It seems like bad in the short run, but in the long run it pays off. I think EMC is brilliant about this stuff. I think, by the way, NAS gets this. So all the storage vendors get this. That's why we all have these features. That's why we have all these cool features to help you buy less storage hardware. Is because we do realize that, we're sort of shooting ourselves in the foot when we do this. in the short term for our revenue, but in the long run, we're going to deliver a better solution for our customers. So when I started my company, that was always what everybody said. When we started Versto, there were two things everybody said. First of all, EMC and NetApp will definitely not allow you to survive, because if you're successful, you'll put them out of business, number one. And number two is you shouldn't bother building this company because VMware is going to make the software themselves, and so you're just going to get run over. And obviously, neither of those things, has proven to be true. This is a hard technical problem. There's a reason why there are so many companies that are solving these kinds of problems, including people like Nexenta there here, Tentry. There's a whole bunch of startups that you guys have never heard of, but you probably will in a few years, that are also working on next generation kinds of solutions to some of these kinds of problems. There's lots of problems yet to be solved. We solve a really big one. We think it's a fundamental platform level problem, but there's lots of problems to be solved here, and they are never going to be solved by simply throwing hardware at the problem. I think everybody's sort of moved beyond that way. So I've got just a few minutes. I'm going to try to run quickly just through a few architecture slides, only because I promised them to you, because we want to get done by 11:45. So you guys mind if I just try to blast really fast? Okay. This is all words on it. So the basic idea here is how do we build a storage layer that's invisible to the layers above us and below us, but provides some very powerful data sort of data services that don't care about the topology, don't care where the disk drives are, don't care if it's rotating or not, but where we treat the VMDK as a center of the universe. So this is at a super high level, the Versto software architecture. So I've got servers. I've got four servers here. Each of them has in it an instance of the Versto software running. Our software, we call vDisks, virtual disks, which in different worlds go by different names. In VMware world, we call them VMDKs. And it presents these virtual disks up to the guest operating system. So the guests just see disk volumes that were the same disk volumes they always saw. They just happen to be instantly provisioned, take up a lot less physical space, and go a lot faster. Other than that, just a standard disk. What we do is we take I/O, we create a separate a device, which is a LUN. We call it a vlog. We make one of those per host. We dedicate one LUN. It's small, tens of gigs, to each host, and we use that to coalesce all the I/O. So what we do is when we've got all these random I/Os coming from 50 virtual machines all on one host, we run them all to one LUN, and we run them sequentially. No matter how random the I/O load is at the layer of the address space, we take all those I/Os and we run them sequentially, always. You cannot do a random I/O with Versto software itself. We will take whatever random I/O you generate, and we will make it sequential before we send it to the disk subsystem. So this thing called a vlog, we create one of them. It's not per virtual machine, it's per host. So we have one instance of the Versto VSA per host, and we have one instance of the vlog per host. And then all of the hosts share the back-end storage just like we always do. And the back-end storage can be tier. Our software does tiering. Most back-end storage hardware also does tiering. Yes, you can do it on either way. You can either use the host-based tiering or the storage-based tiering. And so by doing this, this allows us to take all the random I/O, make it sequential here, and then we destage the data at a later time from here to here. But the I/O is acknowledged as soon as as it hits this. And what this allows us to do is to acknowledge writes immediately in a very high-performance sequential I/O way. Sequential I/O is about 2 orders of magnitude faster than random I/O. That's just the physics of rotating media. And it's quite a bit faster even than random I/O to an SSD. And what this allows us to do is make the process of placing the data in its final proper resting place asynchronous. We can do it when we get around to it. All the data and all the metadata is always there, so anything can die at any instant, and we can always get your data back. So just like any other good disk subsystem, when we say write complete, we mean it. If we say write complete and something dies a nanosecond later and you have to reboot, we promise you that data will be there. It has to be there. So we maintain all the semantics that you would expect a disk subsystem to provide. And it's our job to keep track of, well, was that data still in the log, or had we moved it back over here? Where was it at any given time? And there's a lot of very, very sophisticated ways we make all these I/Os very, very transactional. We never do a half an I/O or sort of almost get it done. It's either done completely or it's not done at all. And we have, the magic of all this is a mapping scheme that maps what looks like simple linear address space to where we actually put the bits, which is really what any file system does, right? We just happen to do it in a way that's very, very oriented towards solving this problem in a very distributed way. We might have 10,000 virtual machines all talking to the same shared storage, and try to keep track of, amongst those 10,000 virtual machines, which bits are shared amongst the MDKs and which ones are in ways that can be arbitrarily complex. So this is probably way too much detail for you guys, but just to give you an idea of how this mapping scheme works. So every disk has its own root, what we call root map block, and every time we make a new piece of storage, we create a new map entry, and we have these hierarchical extensible maps, which again can be arbitrarily complex. This is a spectacularly simple version of what a map would look like. In a large system with many, many VMDKs, the number of lines and pointers here is staggering, and our software job to keep track of all this. This is what allows us to highly, highly share underlying storage, because we can keep track of which bits are shared and which bits are shared amongst which virtual machines in a way that is super high performance. This is all very real time. We do a lot of updating maps as things go on, and you never see a performance impact. This architecture also is what makes it super easy to do snapshots. We've got this log where we're just writing everything sequential. A snapshot is simply, we make a mark, and everything before the mark was a snapshot, and everything after it wasn't. That's why I can make 10,000 of them, because they're really easy. Make sense? So that's kind of under the covers how the software works. And yes, you have a question.
Licensing-wise, do you work with all levels, or does it require a certain level of visa?
Again, the Verso software per se doesn't require any specific level. Most customers are running Enterprise or Enterprise Plus because they're probably solving sort of enterprise-y kinds of problems that they're using our software. So almost of our customers are at that level, but we don't have any specific. That'll probably change once we're part of VMware, by the way.
How is it licensed?
We license per terabyte, so which again may change. I'm telling you right now, the way we do it is we've tried lots of different pricing models. What we're doing now is we're licensing it's a perpetual standard perpetual software license. We're licensing it per terabyte. It's not per terabyte of what you think you have. It's what per terabyte of what you're actually using. Right, so we're reducing your storage requirement by 90%. The number of terabytes is that reduced footprint, not the virtual footprint. Okay, I think we're on the next one.
Thank you very much.
Thank you guys for your time.
Thank you for the I believe Mark, possibly Noel, and Amanda will also be at the VMware, so do tell up with Mark. He's really sharp guys, you can tell. Love to talk more about Versto. Also be there.
With that in mind, I'm going to go through really quickly, but before I do, the more important thing is, why did Technology want to sponsor this? Was it so we could get up here and talk to you about NMC technology that you may or may not need for your environment? Not really. We're relatively new in the space, guys. We have a very good customer base. We have a very strong following up in Orange County, up in LA. Our headquarters are in Orange County. When we built our San Diego presence, it was because we knew that we had a lot of friends locally, and we knew that there was a need for what we do. Specifically, what we do is we have a lot of engineers, and our engineers go out, try to understand what your guys' problems are, and how to fix them. I'm an engineer. I would kill myself if this was my job every day, standing up in front of a crowd. Really, I prefer sitting down with customers, figuring out what their problems are, how to move a 60,000 IOPS SQL database around your environment, and convince your boss it's virtualized when you shouldn't do that. And those kind of conversations, because that's where I prefer. I prefer to stand up with you guys all and do whiteboard session work. We guys come up and move stuff around and design your environment for 45 minutes. That's more interesting to me. Today we brought 3 people. One had to go actually do a customer install. All 3 of them are engineers. Myself, Greg at the back corner, who is definitely here speaking to people, so he'll stay back there. And Alfred left to go plug in some gear for a customer just around the corner from here, because that's what we do. I didn't bring sales reps. I didn't bring CEOs, no offense to you kids. But that's not what we're about when we come and talk to our customers, right? We're about the engineering aspect and what's interesting for you guys. So we'd love to have an opportunity to talk to you guys more in the future about those kind of things. We're not beholden to any one vendor. Specifically, there is a logo on top of that, I understand, but
ultimately, the reason why we chose this technology is because it actually kind of flows well with the whole concept of the virtualization of storage and what the next steps are for your environment and your data center. Mostly marketing, but at the end of the day, the important part of what we're doing here is figuring out how to deliver applications to your end users, right? We've talked about this, a lot of people have talked about it throughout today, but ultimately it's not really about how to keep your servers running, and it's not really about how to keep your storage running, it's about how to keep the applications running, because your end users don't actually log into your storage, and they don't log into a server, right? They use an app, whether it's on your iPhone or iPad or Android device or laptop or whatever. They use applications, and at the end of the day, they're demanding those applications be always available, right? I mean, you know, you pay 99 cents for an app on your iPad or your iPhone, you're still going to raise holy hell if it's not available one day, right? You get really angry about it. So your end user computing is such at home that you expect even more from your employer, right? Basically, data access, right? Again, I can make these slides available to you guys, but really what I want to do is get to the technology aspect of it, right? So this is your traditional active-passive array replication where you're saying everything in my data center is flowing to my storage volumes on the back end. My applications rely on that storage being available all the time. I'm replicating the array so I can maintain some degree of SLAs to keep my environment available. I can fail over within a certain reasonable amount of time. In the event of a major failure, and this is my favorite part of the slide because it's fire, right? Everyone's fire. But ultimately, in the event of a failure, I manually invoke my failover. I say, this is now my production site. I redirect my application stack through my secondary site, and everything runs. That all just takes time, right? What EMC did is they invoked a process, right, an application appliance, that allows you to virtualize that volume, right? Now, a lot of applications allow you, or a lot of appliances nowadays allow you to virtualize a volume. What's interesting is, using a replication technology, right, we can have that volume live in 2 sites. That's still not really cool, right? Because everyone does that. This is the cool part. What you end up with is this distributed virtual volume, which can be actually read and written to in both sites at the same time, right? Now, this has caveats around it. Please don't think you're going to go and build this between here and New York. It won't work this way. There are ways to make it work between here and New York, but there are latency concerns, and it is not fully read-write in both sites. Now, in the event of this failure, your application is actually still completely running because it was already running before. Full read-write, no redirection, everything's just running there, right? So we talked about that kind of automated failover that Lawrence wanted. This isn't solving your problem day to day. It's also cost us a little high for your remote office scenario, but this is the kind of thing that we're looking for, right, to continue the delivery of your application stack, okay? More marketing. So VMware specific integration, right? It looks the same, but it can integrate with that kind of, so again, your traditional disaster recovery, array replication, you can integrate with SRM, you can automate some of that failover, but at the end of the day, there's actually downtime associated with a lot of those events, right? And a fair bit of it usually. So with Dplex, natural caveats, right? Latency is a factor, distance is a factor, bandwidth is a factor. But ultimately, you can use all of these advanced features as if this was in the consistent data center, even though it's in a separate site. Now, does that help you when a major earthquake hits in California and both sites are in California and California is now an island? Maybe not. But does it help you when you have a fire in one data center and the other one is on the other side of town or on the other side of your campus? Absolutely, that's right. Water event, hail event, any of those kind of events that are going to shut off your data center completely, this does help dramatically and allows you to have the functionality of utilizing your resources very well in both data centers, right? The other thing is you waste a lot of money building second data centers that look exactly like your first one. You can't use them for anything because in the event that you are using them for something, and an event happens and you need to bring stuff up, it takes more time to shut stuff down than it does to bring the other stuff up, right? So this is the kind of cool thing I was talking about where, let's say this is New York, and data centers are in San Diego or somewhere close by, right, where you're doing this kind of thing, where we integrate EMC's recovery point technology, which allows you to do the further distance. It does obviously not real-time read-write on both sides, but it does bring those data across, and it gives you the added feature of having kind of that DVR-style recovery kind of section where you can go back to a point in time to logging your writes. Now, I'm going to get to it in a second, but there's going to be slides I'm going to skip because I just want to make sure that the basic message comes across. Why would I come to a VMware users group and knowing that Nexanta's there, Risto's there, Tintree's there, and talk about an EMC product? And the reason is because this has nothing to do with EMC storage so far, right? In fact, these two products specifically, RecoverPoint and Dplex, don't generally care what's underneath them. Now, there is a support matrix. Not every product that comes out is going to be supported immediately, but the goal is to support any block-based protocol underneath all of this, okay? And that's why it's relevant to you guys, because everyone uses different storage, and one of the benefits of a product that sits on top that has a kind of, generic base underneath it is to say, you know what, I don't actually like this vendor anymore. They've stopped innovating. Their prices have gone up. My cost per terabyte's way higher. Someone new came out that's way better for my environment. It makes more sense for me. I have a 60,000 IF database that I want to put somewhere, and it needs to be all flash. Who knows? But ultimately, having technology sitting above it that integrates with VMware, which is what most of you guys care about here, which is why you're here, is really the important part, right? And being able to integrate at this level with your VMware stack without having to worry about what's underneath it is really more the critical piece. I've talked about a lot of this stuff, so I am going to flip through relatively quickly again to save you time and not stand between you and here. That is a bad marketing, by the way, it's standing between people and beer. This one I'm only going to stop at because it's kind of making my point here, right? So on this slide specifically, they've called out a few, right? So you've got IBM, NetApp, DMC, and Freeform listed out. There's a lot more here. It's really, really unclear on this screen, but it looks a lot better on my little screen. I apologize for that. But ultimately, the point here is virtualizing the storage underneath gives you the flexibility to change your storage vendor as you see fit, but also gives you the ability to move stuff around and keep it relatively clean. Now, does storage vMotion give you that opportunity? Absolutely it does, right? Does it allow you to do that between data centers? Not really, right? So this is a way to extend the functionality and the flexibility of that storage vMotion that everyone started to really like, right? Giving them the flexibility, but allowing you to do that outside of your data center and keep that consistent, right? Story slide, we talked VMware and EMC. For those of you who are using vBlock and like the fully integrated solution, right, an integrated point, vPlex integrates very well with vBlock, so does RecoverPoint. So again, if you want the EMC kind of managed stack up the chain, it goes up higher than your existing vBlock today. So again, this is, I'm pretty proud of myself because I'm looking at how long it took, and I'm doing really well so far. But I'm pretty much done. This is almost the recap slide, right? This is basically, it's working for people. It's protecting your data, right? It's protecting your applications, making sure they're available to your needs, keeping your environment flexible, mobile, agile, nimble, whatever you want to call, whatever buzzword that we're going to use today to describe how to maintain our environments and let us keep moving forward in our environments without the pain and heartache of those kind of long migration processes. That's what this allows you to be doing. And my last slide. I think I have one more.
Question. Try again. There you go.
Oh, cool. Sorry. Questions are better than we talking.
So you mentioned sync and async distances. Is that based on latency? Is it distance? What on the support matrix now, and how do they define what fits within?
So there is a support matrix. It changes relatively regularly, and I wouldn't utilize it to design your personal environment. It's a good tool to start with in terms of deciding whether or not you can even come close. As you get there, my recommendation is to engage someone who understands what they're talking about. And the reason I say that is there's really three things, right? One is your speeds and feeds, right? Your transactional load of your application stack, and then the latency is going to be the piece, right? And then all of those are going to be really kind of, you're going to calculate how fast the data gets back up to your application, and then you're going to determine whether your application can sustain that latency, right? That's basically, its application latency is really the most important factor. Those other factors contribute to the application latency, if that makes sense. So, yes, there are maximum distances, but generally we want to be inside those. We don't want to be sitting at that outer edge unless our application isn't, unless our application is very resilient of latency. And most applications that you want to protect with this kind of technology are not. So I would say that in general you want to be relatively close. There are some case studies where this extends quite a ways. I like it as a campus solution. I like it as an in-town solution, right?
The 10, 15 mile.
Absolutely. And again, right, I mean, nowadays bandwidth between those two kind of sites are almost lanes, right? Latency is almost negligible. So, we can go beyond that, and there are people who do. I have customers in Vegas who are significantly further than that, but they're still in the kind of Vegas area. Vegas is a good place for this kind of stuff because so, again, this is the kind of real recap slide that's required in every one of these presentations. But ultimately, right, your failure domains today that you guys have set up are basically, I can move stuff around from one array to another. I can move stuff around within VMware, but right now everything's sitting in one data center, right? And my other data center incurs latency, downtime, and generally reduced RPO, right? You lose data when you move from one data center to another. This is one way for you guys to protect that data, protect those applications, or minimize or completely remove that downtime, right? And that's it, but I would love questions.
Yeah, I think I just want to get the relationship right. So this technology developed the platform was purchased by EMC?
No.
Oh, okay.
But that's a really good question.
So there are three terms here.
I didn't do my job at the beginning, so that's good. But no, technology, we are, and I was kind of sitting over here before when we were introduced, so we're a VAR.
Oh, okay.
So we will sell you the Flex solution, the recovery point solution. We will design your environment. When we were asked if we could help sponsor this, and by the way, my biggest thing I forgot to mention earlier was you're welcome to the bacon. But I think aside from that was my biggest contribution today. But ultimately, that's true. I heard that. A little overdone for my taste as well. But ultimately, right, when we were asked to do this, it was this is a community of people that we want to engage with, right? These are the people who are driving pretty much the IT organizations in all of San Diego, and it was important for us to get in front of you guys and be able to kind of show you guys what we can do with you and for you. And then this technology kind of fit in with, into the kind of virtualized storage world that we were kind of discussing here without being too terribly offensive to the other sponsors that were already on the bus.
And then
we actually do have a couple more minutes of questions for him. Any questions for James or Technologent or any other topic you'd like to talk about? Or do you want us to win an iPad and go get a beer? Yes. iPad. All right, well, thank you. Thank you. Thank you all guys very much. Be sure to reach out to us online or our website. Our all-day meeting is in